Well, good afternoon. My name is Chris, and I'm happy to talk to you about burping better. There are really kind of two concurrent themes in this talk. One is really about finding struts and kind of the best way to do that in an environment, whether it's in your own environment or in a client's environment in a pen test. But then there's also kind of a bit of a John Strand theme here of building things and giving them away. So if you pay attention, I'm sure you'll pick that up. So just a bit about myself, so you have some idea who I am. The last name is pronounced LG, like the letter L and the letter G. I am a nerd at counter-hack challenges, proud to be there with those guys. I do want to mention Sage Data Security too, my previous employer, because I did most of this work on their time, and I do appreciate that from them. I got some certs. I'm also in the Army National Guard. If you speak Army at all, there's some letters, and I feel really so important. All right. So this all kind of came from what I like to call false negative anxiety. Now, a penetration test is not about finding every single thing in a client's environment. If you're hiring a pen tester and they tell you that they're going to find every single thing, they're lying to you, run away. At the same time, if there's something really obvious that you miss, you're kind of letting your client down. So, for example, had I been the pen tester, and I don't know if they had a pen test, but had I been a pen tester a month before Equifax got hacked, I would feel really bad having not found the RCE in their website. And not to pick on Equifax, but it's a case that I think everybody's familiar with when it comes to struts vulnerabilities. By the way, as this goes on, this is a moderately technical talk, and really more looking at the strut side of things than the burp extension building side of things. There was a talk last year in Stables by Sampson was the last name. He talked specifically about how to build extensions. So if you're looking for that piece of it, that could be the piece you're missing. I encourage you to go back and look at that. So things that I don't want to miss as a pen tester. I don't want to miss Cisco, right? If that's there and someone's still got that enabled, I'm going to really feel like a jerk having missed that. If somebody's got a password that's really terrible but not in my dictionary, I mean, that's kind of hard to deal with, but I might miss that. I don't have an easy way to find all those terrible passwords. A really dumb URL with things hidden in it, again, maybe it's in my fuzzing dictionary, maybe I found it with Dirbuster, and then I'm going to feel like a jerk if I didn't. If it's something obvious like this that I just wasn't able to find. Logic bugs, like shopping cart quantities. That's really what humans are for when it comes to web app pen testing, right? Tools like NetSparker can find a lot of the automated finds, but it's really the purpose of having humans is to think about things there and be creative and think that, oh, that TXT file that's being served up, that's actually a log file of admin logons. I saw that recently. Scanners won't typically pick up on that. The last two are also kind of in that same category. When you've got an XML external entity in a website where you're able to basically inject in a call out to another site to pull in additional entities. That's not hard to check for, but it's something that we don't always think to do in every case. Maybe if there's a piece of a web app that involves submitting XML, you might think of that, or maybe if it involves submitting JSON, you think, well, maybe I can switch it to XML and try it. I want to do that. I want to do that automatically every time. Same thing for struts. There are ways to find struts vulnerabilities. And oh, my aching struts. This is just a partial list. These, by the way, on the left-hand side, those are the CVE numbers along with the Apache internal S2 struts2 numbers with them. Those are all RCE. And as you can tell by the years, they come out fast and furious, and they seem to keep coming. As far as finding them, there are plenty of methods of discovering them. I didn't invent any of these. Python scripts in the red box there, because we're going to come back to Python scripts, is a good way to exploit things. In fact, if you look, and I actually built this piece of it before I started working for CounterHack. If you look at the 2017 Holiday Hack Challenge, you actually needed to use a struts vulnerability to get into a web server, to pivot into the internal environment. And there was actually coincidentally, there was a Sans Pen Test blog post about doing that very thing right before the Holiday Hack came out. And by the way, if you do try this plugin, and we'll get there, and you want to scan dev.northpolechristmastown.com, it will pop with a vulnerability for struts, the second newest one, 9805. Another way, sometimes you can find struts with vuln scanners, but that's kind of hard because they can be URL specific. So unless you're feeding your Nessus, Qualys, Nexpose with a full list of URLs, you're probably going to miss that one page that has the vulnerability in it. NSE scripts, similar. There are some powerful NSE scripts, and I love Nmap scripts, but they've got to have that URL list because they're not typically going to do the kind of spidering you need to find these things. ActiveScan++. Has anybody used ActiveScan++? Awesome. So if you're using Burp Pro already, it's a free extension you can get. We're going to talk a lot about it here in a bit, and it looks for cool things, including the Equifax version of struts, the 5638. So here is a Python script. This is something actually coded by Chris Davis. Chris Davis, thank you very much, Chris Davis. Coded this cool thing. It's up on GitHub. And then, long and short, what it does in the top box, I set up my own script for the holiday hack last year where I could just get a shell on a box by feeding a command in. This is what I want the box to do. Please execute this command. And then the script very helpfully hands this big OGNL blob of Java code that you don't really need to understand other than that the struts engine is interpreting this and then taking the command, which was very cleverly disguised with base64 and some T, so you can get special characters through. So long and short, Python script, awesome. I aim it at a specific website, give it a specific command, it executes a command for me. That's awesome. Now, if I have a whole list of URLs and I want to script something to use this script a bunch of times for each of those URLs, you could, in theory, use that to scan for this specific struts vulnerability. But I'm lazy and I'm forgetful, and I want it to happen automatically for me every time. And here's shell. I got ifconfig. Yay! All right. So ActiveScan++, built by one of the smartest web app testers I've ever heard of, James Kettle. If you've ever heard of Albino Wax, if you want to feel really dumb, go look up a talk like Cracking the Lens. The man is absolutely brilliant when it comes to web app pen testing. And he wrote this cool extension and gave it away. Thank you, James Kettle, where it'll look for a bunch of funky side things, including 5638. That is again, the Equifax struts bug. It does require Burp Pro, I'm sorry. It's $350 a year. Also, Jython is a Java Python interpreter that lets you use Python code in Burp, and also Burp Collaborator. We'll come back to Burp Collaborator in just a second. So here's an example of what happens. So you're on a page, you've spidered all your URLs, you're then told it to active scan whatever pages you've found. So ActiveScan++ would already go ahead and give some funky command. So here in the red box, you see a content type, and then like weird code stuff. As web app pen testers, typically we think of injecting funky values in what kind of areas of a request? Form fields, absolutely. Where else? And yeah, absolutely, cookie values. Maybe in the URL, maybe in the host header field, right? With some of these Java strutsy kind of things, it'll be in like content type, or it'll be in the name of the cookie, or maybe even in the name of a header. It'll show up in weird places where people haven't thought to sanitize input. So kind of cool. So what this one does is it throws in a please add a header called exac, and here's some math. And then when it comes back from the server with a response with a new header called exac and the math completed for you, you know that it's vulnerable to 5638. So cool. That's a cool, easy check. All right. Switching gears for just a second, Burp Collaborator. So normally when you're testing, the packets are going back and forth between you and the server, and that's awesome. Or your client's server. It says client. I probably should put client server. Anyway, now sometimes it's useful to have a third party in here, and that's where Burp Collaborator pops in. This is a service that's available to anybody using Burp Pro. You can also set up your own Collaborator server for no additional cost, so that when you send something to the client that's going to cause an external interaction, it'll go up to the collaborator, whether that's pulling an HTTP request, SMTP, SMTPS, or DNS. This will serve as a DNS server, as a web server, all those things, just to receive those interactions so that then you can pull the Burp Collaborator automatically in the background and find out what you've caused that web server to do. Useful for things like blind command injection. All right, so ActiveScan++, it does all these things. I wanted to do more, but I don't want to code in Java. I'm sorry. Are there Java coders in the room? God bless you. Thank you. I don't want to, but I can use Python, right? Because there's this Jython thing, and that's great. I'm much more comfortable with Python. Not like Joff Thayer comfortable, but a little bit comfortable. Also, all right, and this is a coworker saying, just build an extension. I'm like, dude, I don't know the first thing about building a Burp extension. This is in my first year as a professional pen tester. Like I have no idea, but there are already things out there that are similar, like ActiveScan++, where you can just pilfer code, because everybody pilfers code, right? We all Google and take other chunks of code. Some of us are honest about everybody, okay? And then it comes, how do I make it go? Well, there are already these cool existing Python scripts. So at this point, you've got everything you need, right? We can use a language I'm comfortable with. There's also JRuby if you want to code in Ruby for Burp, I guess. There are similar extensions I can pilfer, and there are scripts I can use to rip off. So at that point, it's just a matter of coding it. So that's what I did. I stole Chris Davis's code. Thank you, Chris Davis. And just put these big OGNL blobs that, again, not essential that you understand every piece of it, but you're putting it in the extension, into the code that's already there. Thank you, James Kettle. All right, now this is about command injection, and in a lot of cases, blind command injection. You may get reflection, and that's great, but if you don't, you want something where you're going to be able to detect that, because if your client, if it's buried somehow, you want to make sure that you're detecting whether or not something's happening, right? So I want it to work in a blind context, which means dir, ls, whoami, echo, they're just out. I want it to be cross-platform, and yes, I know there's wget in PowerShell, and that's great, but you're probably not operating in a PowerShell context. I want it to be widely available. NSLOOKUP is great, but if you're in like a bare Docker instance that just has Apache in it, thank you, Daniel Pendolino, you may or may not have NSLOOKUP there, right? That's an additional package that's not necessarily there. I do like it though, because Windows is going to use it, and most Linux distros will use it. I also wanted to go over firewalls, so funky ports are kind of out. I also don't want it to run forever, because again, this is in a client server, and if I'm testing a bunch, I don't want to leave 1,000 running ping processes. So what I ended up with, and this is going to look a little strange to probably everybody, is this command. On Linux, what will this do? It'll ping once. Even though it's out of order, it will, in every environment I tested, it will ping once. But before it can ping, what does it need to do? It needs to look up the host, right? So even if NSLOOKUP isn't there, it's going to resolve that name. On Windows, do you know what this will do? It will not launch calc. I wish it did. It'll actually fail when it gets to the -C1, because in Windows it's what, N1? But before it fails, it will resolve that name. So this is a cheap cross-platform way to get the name resolution. And maybe it will ping out. That's great. I don't care. What I'm looking for in burp collaborator is, did that name resolve? So that's what I'm using in this extension for to check for command execution. So then it comes a matter of, like, hey, I got it, it's up, it's working, and then, new pen tester anxiety, how am I going to go to James Kettle and be like, hey, I made your thing better, right? I'm just some new guy. And then I don't know who Zephyrfish is, but with an avatar like that, it can be a little intimidating, right? I've never seen such a sharply dressed stormtrooper. So you kind of have to get over it, right? And that's what I did. And this is paraphrased a little bit, but basically, I go to GitHub and make my changes, and hey, I'd like you to merge this into the main thing. And I made it, and then James Kettle replies. I'm like, wow, this is the real James Kettle. He's talking back to me, and he says, oh yeah, but you did something kind of funky here. Did you really mean to? Oh, right, yeah, no, that's not quite right. And just based on, we can nerd out later about what was kind of off about it, but I fixed it, and went back to him, and he bumped the version and made a couple style changes, and now it's in the product. So if you've been using ActiveScan++ since like May or so, you've got these changes in there. Thank you. Thank you. My mom loves me too. So look at me now, #2 contributor for this plugin. Thank you very much. All right. And then Homestar Runner wants to know, so what? All right, you made this thing. What has it actually gotten? Interesting thing, I actually found a 0-day in Jamf Pro. It's like an iOS device management thing for enterprises, where it wasn't the struts piece of it, but it was, but with developing those struts little checks, doing an XXE check was actually kind of trivial, because I had all the pieces I need, especially the collaborator interaction. So I found on a client system that if I just defined the DTD, that it would actually resolve the name. And then here, it will make the HTTP request as well. So here's my server listening for, on a specific port, getting that call back. So that was cool. This is basically an SSRF. So neat. Another use of it I thought was kind of cool is if I give it an internal IP address and port, and it's valid, it'll come back in less than a second. If it's not valid, the watch means it took some time, took about a second. Then I know that that's a bad port. So I can use this to port scan inside their environment. That's kind of cool too. I was a little disappointed when I went to report it to them, because it took a while to kind of like communicate well so that everybody understood what I was talking about. And then once they got fully what I was explaining, they said, oh, we're already working on that, which, sure, okay. So to answer your first question, what about the new struts, right? The one that just came out this summer, 11776. That one, we actually got I say we as though, James Kettle and I hang out. But we got a request from Decidedly Gray asking for that, and I looked into it, and it wasn't much different from the other vulnerabilities. The only catch with this one is it's specifically for malformed redirects. So if you are, when you're actively scanning your target, if you're not actively scanning the 302s, the redirects, you're going to miss this specific struts vulnerability because it's in badly handled redirects. So be aware of that. But that is now in as well. And that took just a couple of weeks from the release of the vuln. So that was fun. I speak quickly, so there's time for questions, I believe. What questions do people have about coding, giving things away, and struts? Yeah. Yeah. So it worked. The question was, what was the thing that he wanted me to change in it? And it was actually in kind of how I used the API, because some things are really easy and automatic in Burp, in the way it handles the different methods and objects. Some things aren't. I didn't realize that there was an easy way to have my test insertion happen with every insertion point. So I was having it happen with each request. So it would actually go to. And this was the 2017 Holiday Hack edition of Struts vulnerability. I was having it like cycle through the headers manually to inject the payload into the different headers when there's actually already a different function to do that automatically. So it was just a matter of simplifying that. By the way, if you look at the code, there's no easy way when you're coding an extension to switch a GET request to a POST. So if you're scanning a GET request and you want to maybe switch it to a POST, so you can post an XXE trial into the web application. There's no function to just swap it over. So in the code, you'll actually see me looking for a capital G, like for a get, and then deleting 3 characters, and then inserting POST. And then Burp thankfully takes care of like content length. But yeah, so it was just really that made it a lot slicker. Mr. Thayer.
Is JICOM purely Python 2.7 based, or is there a JICOM 3 as well?
You know, the one I was working with was Python 2.7. I don't know. Does anybody know if there's a Python 3 Jython? Great question.
Project for somebody.
Not a.
All right, thanks.
Thanks, Jeff. Yeah. I'm sorry. Can you say that one more time? Yeah, what resources are useful for building a plugin for Burp? So I wish I'd noticed actually the DerbyCon talk from last year. That would have been helpful to look at. But there's a decent amount of documentation up from Portswigger about all the different methods and objects. So that was helpful. And also just looking at other people's code, looking at the existing ActiveScan++ and some of the just weirdo things it looks for me was really helpful. So if you're looking to code your own, someone may have already done it or what you're trying to do, but I would almost guarantee someone has done something similar. So just look around and see what you can steal. Other questions? Yeah. Does it run passively as well as actively? It does not. No, these checks are specifically active checks. Yeah, looking for remote code execution. Thank you. Anybody else? Well, thanks so much for coming. I appreciate you coming out. Thanks. Like as early as tonight. So. In the National Guard, I am right now an excess staff officer in the NASCAR G6. But I've been everything from SPP partnership director to recruiting battalion XO, force sport company commander, a bit of all of it. Are you a vet, sir?
stand here anyway.
Anyways. Almost put it away without hanging it.
That cable? What do they want me to plug into?
Yeah.
My cable? I assume this is what they want me to use.
Before you plug in, can I look at this really quick?
There's like a breeze right here.
There is.
With
Very
the
unpleasant
string.
stuff. It's very unpleasant.
It is.
Okay, seems good. Hey.
Good. I was just about to plug in. I found this on the floor. I assume this is the cable you wanted. Just unplugged everything and plugging stuff in. Alright, and I see it. Perfect. No. Yeah. We'll just, I was just going to use this one. Yeah. I know, it's so cold right there.
No, I mean, sometimes when I'm talking to the mic, I don't know if I'm close enough or not. It's hard to tell. Are you going to be back there? Just get a signal from that?
So here, just, well, yeah, we'll tell you, because if I'm speaking like this here, you can hear a little bit of echo. But if you're back here, can you still hear me if I'm right here and speaking? Is that okay? Could you hear in the back? Anyone can you hear in the back? No. So you've got to be closer. So if you can hear a little bit of yourself back, then you're okay. Otherwise, assume you're not. Is that cool?
Yeah, it is freezing.
Not quite 5.
Are you going to get the signal start?
Okay, sounds good.
Have presenter view turned off. No, I do have it turned on. They must be duplicating. I broke it.
You broke it. What'd you do?
Tried to turn presenter view on. It went
Why do you
away.
want to do presenter view, huh?
Because then you get a timer.
I'd rather. I don't know. If it's
Well,
gonna
now
break
it's
it,
not working.
Yeah, don't do that. Let's-
I mean, it was already on. Like, I was looking to see if it was turned off. Oh, and I just went back to.
something went wrong.
Okay, it's back.
But now, how do we know what time it is? We're going to use the phone? Is there something on your phone? It's a little, maybe a little bit fast, a little bit slow. Cool. Not ours. That doesn't seem like that's going to be usable. I just want to pull it up on the phone. Is that not okay? No, that's interesting. I just don't see that thing working very well. Do you have a clock app on your phone, or did you get rid of everything? Yeah. If I do like, that's a pain. Yeah, let's touch it. It's fine. I don't know, do you want to do it differently? Like, you can try to get that thing working. I just don't see that thing being used. Did you do it?
Yeah, I couldn't figure out the timer thing. What can I go down? It's at an hour and a half. Every time I hit minute, it goes up.
not very helpful. I think I do. You don't think it stays on if I just do stock watch, it doesn't stay on? I must just unlock it, which I think is what happened at Black. I ran out of time because I forgot to retouch it constantly. Yeah, that's weird. That's not by the default behavior. At least you can show me the stopwatch on my home screen, right? Am I ready?
No, I haven't checked yet. I just didn't want to have it be a puffball in the video.
Fair enough.
Puffball in the video. I'm not paying it to you, but it's still slightly.
Fair enough.
Here's this just in case.
Yeah, that's a good idea. Start the off. I'm gonna start, I guess, unless you want to stay the show. That's what you need.
That's easy much, I think. See the time. I don't care. I know you will. You don't want to be back to the stage.
It's frustrating. This is like way more than I had on my last presentation, which I think is like the best presentation I've ever given.
It's definitely the most interesting thing.
Yeah. I had like a quarter. There's like you and Yoshi and Are we going?
Yeah, the AV guy said.
All right. A minute. All right, welcome everyone. So we're going to talk really briefly about an introduction to x86 assembly. So quick introduction. This is Stephanie. My name is Chris. We've been doing cybersecurity research for about a decade. We also teach classes on assembly and computer architecture at The Ohio State University, and we do some workshops on assembly and reverse engineering. If you're interested in learning more, you can check out DazzleCat Duo for that information. But most importantly for this presentation, we're sort of x86 apologists. We think this is a really fascinating, complex architecture that everybody should know a little bit about. So that's sort of what this presentation is about, is a sort of brief introduction to this. Now, x86 is really, really complex. We can't cover everything in the next 25 minutes. So our goal today is sort of to start with zero knowledge. Maybe you know a little bit about assembly or x86. Maybe you know a lot. Maybe you know nothing. We're going to assume that everybody knows nothing, and we're going to try to get to the point where we can all write a hello world program, which I think will put everybody on good footing for learning a lot more if you're interested in pursuing this further. But the premise behind all of this sort of starts at a very, very low level. That's what assembly's all about. And the idea is that everything your CPU does ultimately comes down to digital logic, right? On and off, ultimately running current through transistors or not, which we abstract away as the idea of either 1 or 0. Now, if you think of these ones and zeros, the way a computer chip is designed is it's designed to accept a stream of these ones and zeros and basically do things based on the specific stream that you give it. And if you think about a stream of ones and zeros, essentially what you have is just a bunch of numbers that ultimately tell your CPU what to do. So we call those numbers machine code. And if you break those bits, those ones and zeros, into groups of 8 and change it into hexadecimal, you end up with something that looks like this. So this is what we would normally think of when we think of machine code, just a big stream of hexadecimal bytes. Now, ultimately, this is what your CPU is after, right? This is what tells the CPU what to do, when to do it, how to do it, etc. But humans don't think this way very, very well. We need some sort of abstraction around this. So whereas on the left is what your CPU CPU wants. On the right is a way that's a little bit easier for us to think about that information. So on the right is what we call assembly. It's a light abstraction over machine code that makes things easier for us to read. So for example, I might want to tell the CPU, well, return from your current subroutine. So I can just remember that that's the ret instruction instead of having to remember that the machine code behind that is the number C3. And you can see that although assembly isn't the easiest thing to read, it's a whole lot easier to start making sense of than the machine code. So for example, even with just a little bit of knowledge here, we can sort of infer that, well, this first instruction pushes something onto the stack. This next one copies something from one value into another. Then we do some arithmetic, then we call a function, we leave the current stack frame, we return from this function. So you don't need to know exactly what each of these do, but you can sort of get a sense for what's going on at the machine code level if we can read this assembly abstraction of that information. So ultimately, as humans, it's more practical for us to write in assembly, but that lets us get about as close as we would ever want to get to communicating with the processor itself. So fortunately, we don't need to understand exactly how to do that translation between these two abstractions ourselves. If we want to write in assembly and we want to get that into a state that the CPU can understand, we can use a tool called an assembler in order to convert our assembly into machine code. On the other hand, if we want to go in the other direction, if we want to take machine code and bring it into something that we can understand, if we want to take that into assembly, we can use a disassembler in order to do that process. So now that we sort of understand the premise of what we're looking at, we need to pick a specific architecture, a specific assembly language to dive into in a little bit more depth. So let's look at x86. So a lot of people will shy away from x86. If you don't know a lot about assembly and you haven't really looked at a computer from this perspective before, a lot of people will tell you stay away from x86. That's not a good place to start. And the reason they'll say that is x86 is just insanely complex. So people will say it's not a good language to start with. And I actually don't think that's the case. I think x86 is the perfect language to begin learning if you're interested in diving into assembly. And the reason I say that is that with x86, you can build and run and play with the language on your own computer right now. You don't need special hardware. You don't need emulators. Basically, every one of you could pull out your laptops and start using this immediately. And I think that makes it a great learning tool. It's also extremely popular. It's present on billions of systems worldwide, has total market dominance in the PC space, which means that there's plenty of learning material. You can start diving into any of the applications on your computer right now and pulling them apart in order to learn more about how they work. And it forms a core of a lot of familiar operating systems, Windows, Mac, Linux, all sort of built in one way or another or in one flavor or another on x86. So I think that makes it a really, really good language to start with, despite its complexity. But that's not to say it's not complex. It is. The Intel Software Developers Manual, what we call the SDM, is sort of the go-to reference for learning x86. You can find it here, but it is 4,000 pages long last time I checked, and it does not even begin to scratch the surface of all of x86. The reason I point this out is there's no way in a 25-minute presentation we can really get deep into this. So our goal moving forward is basically just to give you the basics, give you enough that you can get started if you want to go out on your own and dive in to some more depth. So with that, I'm going to hand things over, and Stephanie's going to talk about the actual technical aspects behind all of this.
All right, so x86 assembly. So we kind of introduced the topic. I'm going to introduce that there are two main rivals of x86 syntax. So despite x86 being a known architecture, there's actually no one way to write x86. It's actually dependent on what assembler you're using. So there are two of the largest competitors in the x86 syntax world are what you'll see called AT&T syntax and Intel syntax. And both have pretty good market dominance. They both have their pros and cons. There are hundreds of smaller ones. For the purposes of this presentation and my own personal opinion, I think AT&T is horrible and hard to read. So it's the one on the top. And we will be focused on Intel, but if you're ever looking up x86 and you see all these weird like percent signs and dollar signs everywhere, you are looking at AT&T syntax. So make sure you just understand some of the small nuances. It's still x86 assembly, it's just a different syntax. If you don't see all the percent signs and dollar signs, you're probably looking at Intel syntax. So assembler syntax, I said it depends on your assembler. There is no one right way to write x86, which is different from most programming languages. It all depends what assembler you're using. So the assembler that is most commonly used, and the one I'll introduce, is called NASM. So NASM is a Linux-based NetWide assembler, it's called. So NASM syntax, it's Intel syntax. Lines don't end in a semicolon. Semicolons start a single line comment. So the last line there shows you instruction, and then colon would be a comment, otherwise a colon's not necessary. So some x86 instructions. So the first thing you need to understand before we show you instructions is how you use registers. So the registers are how your processor actually stores data on the processor. System memory is extremely slow, and extremely slow seems kind of odd to think of your system memory. Memory is fast, and it's gotten a lot faster, but compared to a register inside of the CPU, it is thousands of times slower to fetch something from memory than it is to fetch it from one of the CPU registers. So the registers are your preferred way of handling and manipulating data. If you can avoid memory fetches, you want to for speed reasons. Registers are actually inside the processor physically. That's why they are so much faster. So we're going to focus on the 32-bit registers. In this particular presentation, know that the 64-bit, everything we're learning here, it still applies to 64-bit registers. It's just that you put an R in front. So instead of EAX, it would be RAX. It's just a 64-bit version of the same register. Everything else still applies. So the naming convention for the 32-bit registers, you'll see that you really only have these 6 general purpose registers at the top. So EAX, EBX, ECX, EDX, ESI, and EDI. So the top 4, you can refer to smaller versions of them. So you see you can look at like AX as just the lower 16 bits of it. And that's because x86 has been around since the 60s and 70s, and it has been backwards compatible since then. So the current x86 manifestation is still backwards compatible with the original like 16 and 8-bit versions of the architecture. And that's why you have these old historical versions of these registers, because original code written for the original 8086 and 8087 would still run on a modern processor. So the other instruction, or the other register worth knowing, is EIP. So this is your instruction pointer register. You have no direct control over this. You can't load it. You can't use it like a normal variable, but it always contains the memory address of the next instruction to execute. So anytime you're doing debugging, the EIP one is one you're going to want to pay attention to, and it's the next instruction. So not the one that's currently executing, but what will be next if you were to step through your code. The other important thing before we introduce actual instructions is how you actually access memory. The registers are the preferred way to do things, but routinely stuff is stored in memory, or you saw you really only have 6 registers. And for all the complex things your computer does, there's no way to do that entirely in those 6 registers. So you will routinely find needs where you have to store things in memory and refetch them. So if you're going to manipulate memory, you simply put the memory address inside of square brackets is how you're telling the CPU basically go to that memory address and fetch the information at that memory address. So Chris had mentioned that the developer manual for x86 is 4,000 pages. Truthfully, if you just learn the instructions that I show on this page, that is going to get you 95% of the way. Chris and I consider ourselves to be x86 experts, and I would guarantee if I looked through that developer manual, there'd be a ton of stuff that I didn't know, because the truth is you don't need it if you're doing x86. It's all really obscure corner case stuff. So these are the instructions you're going to want to focus on. I'll introduce most of them today, but when you're going back or people watching this video, kind of look at this slide, and these are the instructions you should learn to be able to actually do x86. This is one of my favorite references. So if you're on your computer and actually trying to look up x86, this is the one I always go to for quickly looking up x86 instructions and quickly how they work and how they assemble. So the most important instruction is the move instruction. And despite being called move, it actually makes a copy. It does not move data. So the way it is move and then destination source. This is the biggest difference between Intel and AT&T syntax. AT&T has source and destination flipped. So if you're looking at AT&T syntax, everything is reverse order from Intel. So the Intel syntax is destination source. And then I've got examples down there, and I kind of have that part where it says copy underlined, because people when they're starting get very confused by the fact that it's called move. If I am moving from, say, memory address 100 into EDX register, that original data's value still stays at memory address 100. It is not an actual move, it is a copy. Same for the last one. So if I'm moving from the EAX register into the EDX register, EAX still maintains its original value. I've simply made a copy of it. So it's called move, but it's actually a copy instruction. So add and subtract. So for Intel, just ubiquitously, it will always be destination first, and then whatever other value that instruction needs. So if I'm adding something, I have destination and value. So the interesting things about add and subtract is there's only 2 arguments. So your destination is always one of the arguments. So if I'm adding add EAX and then this long number, EAX is both used in the equation and is the destination. So your destination is always part of the equation. You can't save it in a third variable. So it's important to understand you're also overwriting one of your variables when you're doing an add or subtract. So the jump instruction, x86, like all coding languages, executes linearly, so it'll just keep going unless you hit something that will change or divert the EIP register. You cannot affect the EIP register directly, so the way you affect it is things like jump instructions. Jump will load the address that you have there into EIP so that the next instruction will be that instruction instead of the one that was after it. So in this case, jump begin, I'm telling it that the next instruction I want you to go to is a place that I have labeled in my code called begin. So an example of this to implement a loop. So real quickly, I move a 0 into EAX, so I'm setting using EAX kind of as my loop counter. I'm going to increment EAX, which just adds 1 to EAX. So on first increment, it would be a 1. And then I'm going to jump loop. So that just loads the loop instruction, the address, which was 1 line ahead, into EIP. So the next instruction would go back up and increment EAX. So this is actually an infinite loop. EAX will indefinitely increment. I'll show you how to not have an infinite loop later, but just introduce the jump instruction. In this case, it's what we call an unconditional jump. It will always take the jump, which sometimes you need, but sometimes you need some that are conditional. To have a conditional jump, you have to do some kind of a comparison. So I have to have some kind of a statement that I'm trying to say, well, if this, then jump. If not this, then don't jump. So I do that by using things like comparisons. So the compare operator subtracts the second operand from the first operand. The results are discarded. So what I mean is if I compare a 5 to a 3, 5 minus 3 is 2. The 2 is discarded. That doesn't overwrite any of the operands, but the fact that it was a positive 2 is used in the next instruction to decide whether or not you are going to take that jump. So here's an example of it. So why is this useful? So if I load 100 into EAX, a 200 into EBX, and do a compare between the two, what that's actually doing behind the scenes is EAX minus EBX. So I'm going to get 100 hex, a negative 100 hex. And what that's actually going to do behind the scenes is basically just set the knowledge that the information was negative. So if the result was negative, you get this SF, which is the sign flag. But all that's relevant to you is that the computer now knows that the result was negative, which meant that EAX is smaller than EBX. That's really all you have to understand. So reverse opposite of that. So now EAX is bigger than EBX. So if I load a 300 into EAX, a 200 into EBX, and do the compare, it's still going to do the 300 minus the 200, but this time I get a positive number. The fact that it's a positive 100 is irrelevant. All the computer cares about is that it was a positive result, which meant EAX was bigger than EAX. So that knowledge is what the computer is then going to use when you do then conditional jumps. So how do I do a conditional jump? So conditional jumps take into consideration the state of the CPU. So the CPU is tracking the fact that the last compare resulted in a positive number. So it meant greater than. So I get all these different possible control flow instructions. So jump equal. If the last compare, the numbers were equal, then jump equal would get taken. Jump not equal is the exact opposite. So you also have your jump 0, jump greater than equal to, less than, and less than equal to. So you can just kind of imagine the truth table with that compare instruction of if the numbers were less than, if they were equal, if they were greater than. I would use the various conditional jumps based on what I was trying to achieve. And remember, this is a 25-minute intro, so jumps are kind of complicated. But this is the basic to the logic you need to be able to make code that is not stuck in an infinite loop and does something conditionally. So here, a different example of how I could have done a loop. So I compare EAX to EBX, and then jump less than equal to done. So in that case, I'm comparing something, and if it is greater than, I want to keep executing. But if not, then I'm going to say, well, if it's less than or equal to, I'm done. I'm exiting my loop. So that's how you would do the equivalent of what you would think of as a conditional loop in any other language. So here's one. I want to loop from 0 to 5. So instead of incrementing EAX indefinitely, I only want to increment it 5 times. So load a 0 into EAX by a 0 moving into EAX. I'm going to increment EAX. I'm going to compare EAX to 5. And if it's jump less than or equal to loop. So if EAX was less than or equal to 5, I jump back up and do the loop again. So what that means is when EAX is greater than 5, I will not take the jump and I will end the loop. So now I've got the ability to do conditional looping. So different conditional. This one, it's not a loop. Now I have an if statement. So think of if statements in any other higher level language. If A is equal to B, I want to set some values. In this case, X equals to 1. So I'm going to say compare AX to BX, which is taking AX minus BX. And then if it's jump not equal to skip. So if they were not equal, then I want to jump over the next instruction. So you see how the skip label is lower. So if they were not equal, I'm going to skip the next instruction. If they were equal to, I will go ahead and execute the next instruction, which moved a 1 into CX. So in that case, now I can do things like if, else statements, else ifs, using the compare and conditional jumps. So functions are another big thing you're going to want to be able to do. So think of call as the way that I invoke a function. So I would call and then the name of my function. In any higher level language, you would still put the name of the function just without the keyword call. This time you just have to add a call in front of it. Ret is how you return from one of your calls. So once you're inside of a function, if you're done with that function and you want to go back to where it was initially called, use the ret instruction. So no-op is a particularly popular one in the security field. So no-op or nop literally does nothing. It wastes 1 CPU cycle. It's often used nefariously for things like nop sleds and nopping out security checks. So if there's a piece of code that I don't actually want to run for security reasons, say I'm trying to get past your authentication, just fill it with nops, which is a machine code 90. The legitimate uses for it are for timing, trying to get code to be aligned. So it literally just tells the computer to do nothing, but it does it in a valid way that won't cause any crashes. So nops can be useful in the right situations. This example, I'm not going to go through it line by line, but I wanted it to be in here, so if you go back and reference the video, you can have some code. But in a 25-minute talk, I can't actually go over the whole thing. But here's an example that will actually show you just kind of how you would take a piece of pseudocode, in this case, some really simple addition and setting up of variables, and actually do some simple arithmetic on it. So that example is there for you guys to reference later. So the other important thing I want to introduce is the fact that you will need the operating system's help if you are writing x86. While it is true that you could literally do everything by writing at x86, if you wanted to turn on or off a pixel on your screen in pure x86, you're going to be writing thousands, if not tens of thousands of lines of code. It is not fun. So there are times when you actually want to ask the operating system to help you a little bit, even though you're writing in x86 assembly. So in Linux, we do that through what are called syscalls or int80s. So syscalls ask the Linux kernel to help you out. Say, Linux kernel, can you actually do a basic piece of functionality for me? So I'm going to introduce the 2 that we need for Hello World, but I've given you the links here to look at other system calls that you can easily invoke from x86 assembly to ask the Linux kernel to do things for you. So the first one you need to know is a syswrite. When we're writing Hello World, if I actually try to write the text Hello World to the screen, I could do it in pure assembly, but we're talking tens of thousands of lines. That one may be hundreds of thousands. So I'd rather ask the operating system to help me out using a syswrite. The way you do that is you have to preload particular values into the appropriate registers and then invoke the operating system. So for a syswrite, I have to get a 4 into EAX. That's how I tell the Linux kernel that I want a syswrite. It's function number 4. In the EBX, I put a 1, which is telling it to write out to the console. So this will write out to a terminal. In ECX, I'm going to put the string I want it to write. And in EDX, I put the length of the string. So an example of that would write out to the thing. And then the int x80 is the thing that says, all right, Linux kernel, do what I just asked you to. So an int 80 is how you actually invoke the kernel. The sysexit is the other one. So if you want to actually exit cleanly from your application, you don't want your assembly to just stop. You want to tell the kernel, hey, I'm actually done, clean up this process. So at sysexit is how you do that. So putting it all together, I won't go through this in detail, but again, this is here for the video. So if you are going to start writing x86 assembly, this is how you will want to set up your file. Everything you see in black are keywords that you actually need to have in your file. And then where you see code goes here, variables go there. That's where you would put your code. That's where you would put your variables. This is just showing you examples of how you declare variables. So how you would declare ints, strings, anything that you might need in your code. Then putting it all together. So this is how you're going to actually build x86 assembly in Linux. So I told you we were going to use NASM, so you're going to invoke it with that first line there, NASM felf. Felf is telling you elf is the executable format for Linux. So you were saying build me something that can execute in Linux. And then linking it together is how you actually then link it so the operating system knows how to find all of the calls it was using. And then the dot slash is how you would run any executable. So that's just putting it in more detail, what NASM is doing with that command. The linker, you are telling it to link this with x86. That's what the melf i386 is doing. If you want to disassemble it, so you want to see what you actually built, object dump is built into all Linux distributions. So you will do the -d to tell it to dump the code and data section, and -mintel tells it to dump it in Intel syntax, because none of these tools agree with each other. So object dump defaults to AT&T syntax, NASM defaults to Intel syntax. So you need the mintel. You can throw this all in a make file. So here's a sample make file, so you don't have to type that out every time. If you do these -gs, we'll add debug symbols into your x86. So if you are writing assembly to debug it yourself to learn better, put the -gs, and that'll leave the debug symbols so it's easier for you to look at what got actually built. And then here is a Hello World application. So when you get home, pull up this video or take a screenshot really quick. And if you write this into a NASM file, build it with the NASM and link it, this will actually print Hello World to the screen.
So that's sort of wrapping it up, a really quick crash course into x86. I think a lot of people want to know, like, where do I go now? Yeah, can you turn that down? Where do I go from here? One thing I find when a lot of people are starting out with low-level assembly is they don't really appreciate the power of it and what you can do with it. And the fact is, like, x86 is Turing complete. It's as powerful as any other programming language that we might use at a much higher level. We can do anything in x86 that we could in any other language. And sort of as a way of pointing that out, since I'm a 90s kid, I spent a lot of time playing Roller Coaster Tycoon. This game was written in 99% directly in x86 assembly. It made hundreds of millions of dollars. It's a kind of a jumping off point. I think the best way to learn more is to basically just start with the building blocks that we discussed today and start trying to add your own additions. Just start using it to build tiny programs, start tearing apart other people's programs, see how they work. That's sort of the way to improve your knowledge of this. And again, like I said, sort of the sky's the limit with what you can do with this. So I hope this has been helpful, and we're out of time now. But thank you everybody for attending.
Cool. I think it's. I think everything's good. Just use this microphone, right? Yeah. Hello. Testing.
So if you can hear yourself that way, if you can't hear yourself that way, realize it's not as loud as you think.
Okay.
So I don't mean you have to lean over, but just lean.
All right. Sounds good. I don't think so. I think I'm good. Thanks. Okay. Yeah. Anyway. Oh, no. Good. I'm going to get started here. So, hi everybody. My name's Spencer Geetson, and today I'm going to be talking to you about Pacu and AWS exploitation with Pacu. So, a little bit of an introduction. I'm a pen tester with Rhino Security Labs, and main focus is on the cloud, and even more so on AWS than any others. I've got a background in software development prior to my pen testing experience, and currently, I'm the lead developer of Pacu and CloudGoat, which Pacu talk about today, and CloudGoats are vulnerable by design AWS environment for learning Pacu and learning AWS pen testing. So AWS security is pretty easy to get started with, but it's hard to master, and there are quite a large amount of good resources out there, like AWS documentation or white papers or just blog posts from various different researchers. But it's really difficult to know if you're doing it right and doing everything right, and so that's kind of where Pacu was born from. In a lot of cases, best practices are not going to solve all the problems that you're going to encounter, and features aren't always your friends, so something that you think was useful might come back to bite you in the butt later. Most common example of not doing it right is the thousands, seemingly, S3 bucket misconfigurations over the past couple of years, where people are just leaving their data wide open to the internet for someone to find, and over again, this example right here on the side, you might recognize it. It's looking at a listable bucket online. It's got all your phi.sql.back, credit card info.csv, clear text passwords.txt, a little bit of an exaggeration, but it almost is literally what we've been seeing over the past couple of years. And S3 bucket misconfigurations are one thing, but the real threat comes in with authenticated compromise, and you're at a much higher risk of, lots of different kinds of attacks if you lose your keys versus just somebody discovering your open endpoint on the internet. There's a lot of different ways keys can get compromised, and some of those include repo misconfigurations on GitHub, pushing some keys you had stored in a file or something like that. Social engineering and phishing to get people's usernames and passwords for their accounts. Password reuse, this is something I encounter quite a bit as a pen tester. I can go online and look at a database dump, find a clear text password for someone, and then I find that they use that same password for 10 other services, and I've owned their environment through that. It's really, really common. Web application vulnerabilities are even more common from what I've found. With server-side request forgery, you can contact the metadata of an EC2 instance, which gives you temporary credentials if there's an associated set of credentials for that, as well as local file read through really any method, just to read, configurations, logs, and other files that might contain credentials. Trusted third parties are another big one. A lot of integrations exist where you allow a third party access to your AWS environment to do whatever it is they need to do. So that means if they get compromised, you're at risk of being compromised. And then internal threats and rogue employees. This is something that I don't think is thought about as much, but it's a much higher risk in the sense that there's a huge barrier they don't need to overcome that normal attackers do. And it's the initial access. They've already got access to your environment, so if they're overly permissive, they could really harm your environment. In general, there's a lot of tools out there for scanning your AWS environment and checking for best practices. Some of those include Prowler, Scout2, and CloudSploit, really good tools. I use them myself. But there wasn't much for attackers previously. There were a few tools, AWS Pwn, that's one of my favorites. Nimbostratus and Dumpster Diver, great tools as well. But something more was needed, and so really that's where Pacu was born from. So AWS Exploitation Framework, it's written in Python 3, covers the whole kill chain, so reconnaissance, enumeration, logging and monitoring disruption, persistence, privilege escalation, data exfiltration, just general exploitation. We try and include all that in there. It's simple to start developing modules. There's a built-in template that I wrote. You can literally just look at it and start writing Python code using the Boto3 library, which is the AWS Python library. It's extensible, so there's a built-in API to assist with development. It takes a lot of unnecessary code out of your hands, a lot of repetitive code out of your hands, makes it easy to get started. And there's built-in session and data management. A session is basically just a project or a company you're working on, and it houses all the keys and everything that are associated with that session. And the various data that gets stored is basically just the data of the AWS account. So EC2 instances, S3 buckets, and tons of other things. That's all stored in a local SQLite database that's queryable from within the Pacu modules, and it's easily modifiable and readable. And then there's general error handling that you don't have to worry about corruption of the database or anything like that. It's going to handle all those errors. It's not going to blow up your screen with a huge error message, but if you want to go look into it, there's also stored files with those big errors. And just a note, it is available. I've had people think that it was not yet released previously, but. So I'm going to get into the demo, the most important part of this presentation. It's a post-compromise scenario, so I've just gotten someone's keys through some method. I've compromised them, I don't know anything about them. I'll run through an intro to Pacu and just how to generally use the basic commands. Some basic account information that's not logged in CloudTrail, which CloudTrail is the main logging source of AWS. There's recent research I discovered that you can get some basic enumeration without any detection there. And then I'm going to enumerate IAM permissions for the current user. I'm going to escalate those privileges to an administrator and establish some persistence within the account. And I'm going to finish off getting root remote code execution on an EC2 instance within the account. So I've got a server set up here, or a shell. I can start Pacu just by running Python 3 Pacu. Enter it, it'll pop up. It said it's found some existing sessions. I set one up for DerbyCon already. So hit one, enter into that, and we can see that the help message, there's quite a bit of help info that pops up because there's a lot of different commands you can run. Ignore it for now, but at the bottom on the Pacu shell, as I've been calling it, we can see DerbyCon. That's the current session we just chose. We just logged into this session, and then there's the Derby user, and that's the active set of AWS keys for this session that I set up prior to the presentation, but these are the keys that I've just compromised. So some basic commands, got ls, and hit enter, and that's going to list out all the modules that exist as well as the different categories that they belong to. So there's reconnaissance without the need for keys, enumeration, privilege escalation, lateral movement, exploitation, persistence, exfiltration, and evasion. There's the search command, so you can search for any module with EC2 in the name, search EC2, and it's going to print out basically the same information, except this time it's going to have a one-sentence description of what that module does, and give you a better idea what you're trying to do with that module. But there's a lot more help for each of these modules. With the help command, you can pass in a module name. So I'm going to pass it in EC2 enum, hit enter, and it's going to print out all the available arguments for that module, a long-winded description of exactly what it does, and then just how to use it and everything. So if you ever don't know what a module does, that's where to look. So there's also the set keys command. This is what I use to set up my Derby user. I don't have any keys I'm going to add right now, but I'll just show you anyways. You hit set keys, and then you can pass in an arbitrary name. I passed in Derby previously. And then you can see the access key ID for your API keys, the secret key, which gets, well, it's not censored anymore. It's all right. So it's not, well, it is censored here. And so basically that it doesn't happen and the keys don't get posted on the screen, but it happens, doesn't matter. Session tokens for temporary credentials. These are not temporary credentials, so I don't have a session token, that's empty. So basically, that's that. And once you say I did just enter in a new set of keys, there's a swap keys command, and that'll list out all the active keys within this session. And so I don't have any others, so I can just stick with this current one. There's also, it's a really important command, the set regions command. I'm going to set the regions to US West 2 because this demo is solely focused on the Oregon region. So what this does is when any module runs that accepts regions as an argument, it will first get the valid list of supported regions for the service that you're targeting, so EC2, let's say, and then it'll compare that against the list of session regions, and it will create a third list that is the regions that are in both of those previous lists. So what this does is we'll make it so that Paku modules will only ever run against regions that are supported for a service, as well as only regions that you want to be targeting in this session. So there's no accidental stuff going on here. I can show you the whoami command, run that. We don't know anything about this user because I haven't run any commands for him, so everything's null. But it basically just a lot of identifying information about who the user is, any groups they belong to, policies that are attached to them, as well as their permissions, which can get filled in shortly here. So going into the non-logged enumeration of the account, I created a module for that, which is IAM detect honey tokens, which basically the research ended up in being able to detect when AWS keys were honey tokens without triggering the alerts for them. Contacted the vendors, everything. They decided they fixed that. Contacted AWS about this. They said it's not a problem, and they closed the ticket. So take that as you will. Run the module. We can see the module determine these keys are real and not honey tokens as far as it knows, as well as it gives you the Amazon resource name of the keys, because this service that it uses is AppStream, which is unsupported by CloudTrail, and AppStream, as well as some other services, disclose some verbose error messages that includes this information. So now if I run whoami again, we can see the username got filled in, the ARN got filled in, and the account ID got filled in. And it's not a ton of information, but nobody knows I did it, and there's no way for them to know that I did it, really. So from this point, I can run the IAM enum permissions module. And this is going to gather the list of permissions that my current user has so I know what I have access to. And we can see it confirmed permissions for Derby, and we get a module summary for every module that runs. And it says we confirmed permissions for Derby and then 0 roles. It also supports roles. The idea is if it just confirmed permissions for 50 different users and 25 roles, that would fill up your whole terminal, but the summary would give you a better idea of what exactly went on if you didn't want to go reading through all of that. So now if I run Who Am I again, we can see that this information got filled in, the rest of it. We got the user ID, just all this top stuff's identifying information about this account, not all that important right now. These are the policies that are attached to that user. So I have one policy, the IAM manage self policy attached. And then permissions confirmed is set to true, which means that my user had the right set of permissions to determine exactly what permissions it has, if that makes sense. Kind of weird point, but it's possible to not have that permission and for this set of permissions here to get filled out but not be complete, and so in that case it would be false. We can see under allow, I'm allowed the IAM list star permissions, and star is a wildcard in IAM policies. They're just JSON documents, so a star means I can run any list command within the IAM service, and then resources are just resources within the AWS account, and I have that permission on any resource in the account. Same goes for IAM get permissions, and then I have the IAM put user policy permission, which is allowed only on this single resource, and this is the ARN or Amazon resource name of a user that is in this account right here. This 12-digit number is a user, and it has the developer path name associated with them, which we know my user does from right here. And then AWS username right here, this is an IAM policy variable that when you execute an API call, that's going to resolve to who is executing that API call. And so basically, I can only run the IAM put user policy API call on my own user. As another example, I included the IAM generate permission, which has a condition that I only have that permission if I'm multi-factor authenticated with AWS, and it's not important right now, but it's just an example of what this kind of information shows when you run that. So we know that I don't have any EC2 permissions, but just a quick example, I can run the EC2 enum module, pass it the instances argument, and it's going to fail. It says I don't have permission to run describe instances. That's what we expected. So I'm going to escalate my privileges now, hopefully. I can run the IAM privesc scan module, and basically this module will scan my permissions for 21 different privilege escalation methods to determine what it has access to, and then it will try to exploit any of the available methods through that show up. So hit enter. So it happens quickly. We can see that confirmed put user policy, that's one of the methods that it discovered, put user policy, and that's the only method, otherwise they'd be listed there. So then it's going to attempt to start exploiting that privilege escalation. It's going to use it to add an administrator level policy to this current user, and then it tried that and it was successful, and it created this policy with administrator level permissions. So, you know, it doesn't look like much, but I can run the IAM enum permissions module again to get my new set of permissions. And if I run who am I again, we can see right here at the bottom of the allow permissions, I have star permissions on star resources, which means I can run any AWS API call on any resource within the AWS account. So basically, that's an administrator level access to this account. So to show that even further, I can run the EC2 enum module again, and this time it's going to work. I found one EC2 instance in the US West 2 region, and so we know that I actually do have those administrator level permissions. In terms of persistence, because of, well, time constraints, I'm not actually going to run through these modules, but I'll describe them a little bit. So there's the EC2 backdoor security groups module. It's going to whitelist an IP range of your choice to any security group within the account. So then you'll have access to the various servers and services that are available. There's backdoor assume role, which will give your user permission to assume other roles in the account, which can give you 12-hour, I think 12 hours is the maximum access to those roles as you get a new set of keys, basically. And then there's the IAM backdoor users keys and password modules, which will add either a set of keys or a password to other users in the account, and you can have access to all their permissions that way. And just recently I added these 3 modules from AWS Pwn. I ported over some scripts that Daggers had written, and basically what they'll do is they'll launch a Lambda function and a CloudWatch events rule into your account that will monitor the IAM service. So every time a new role is created, it will automatically backdoor it with your account and then exfiltrate the role's Amazon resource name or ARN to your server. So then you know you can go and assume that at any time. Or with security groups, it'll backdoor it with your IP every time someone creates a security group. And for new users, it'll backdoor a new user with a set of keys, and it'll exfiltrate those to a server that you've set up. And then you've got literally access, unlimited access, until they figure out that this is going on. So we'll say we just established some persistence. From this point, I'm going to get some code execution on that EC2 instance we discovered. And there's a couple of modules that do that. There is the Systems Manager RCE EC2 module. It uses AWS Systems Manager to get root or system code execution on various EC2 instances that it doesn't require a restart, doesn't require anything. It's pretty simple if you have the permissions to do it and the operating system is vulnerable. But it's a little finicky with time, and so it's not a very good module to show in a presentation. I'm going to show the EC2 startup shell script module, which will stop an instance, change the user data of it, which the user data is basically just an arbitrary set of script or data or whatever that you want to supply to the instance that the instance will then have access to. But there are directives you can pass in that will instruct the instance to run this section of code that you stored in the user data on startup. And it runs as root on Linux and system on Windows. Pretty easy and pretty simple set of permissions that it takes to do this. Obviously, it's a problem to stop an instance in an engagement or something like that, but if you are able to do it, it's a real easy way to get code execution. So I've got another server set up here. I'm going to set up a Netcat listener on port 5050. Just going to listen for my reverse shell that I'm going to send it here in a second. And then I'm going to run the, let's see, EC2 startup shell script module. I'm going to pass it a script that I've already written, reverse shell.sh, and it's just a bash reverse shell that points to that server that we're listening on right now. So we'll run this, and it's going to target every EC2 instance because I didn't instruct it to target any particular ones. It's going to immediately start stopping it, and once it stops, it's going to start setting the user data for it, and it's going to insert my script without screwing up the user data. At least in my experience, it will add in this script without screwing up the previous user data that they have set up for their instance. So you wouldn't be necessarily causing any denial of service or anything like that. So now the instance has stopped, and it started it up again. And once the instance starts, we'll see on the reverse shell that during the boot process, it's going to read that script and execute it as the root user, and it's going to make a callback to this server I've got running. And this is always a little nerve-wracking. I know it's going to work, but it takes a second. So there's the shell that came in, the root user. You can run who am I, and that's the root user. So that wraps up the demo here. Pop back to the slides. Basically in conclusion, there's a lack of security tools or AWS security tools in the industry, and that means there's a lack of AWS security awareness because people don't know what's possible in their environments. They don't know what the features can do. We're going to try and solve that with Paku. That was the goal, and more offensive research from myself and hopefully from the community as well, and make it easier to understand what's going on and easier to secure your environments. I've included some resources here. This blog post that describes the 21 different privilege escalation methods that the privilege escalation scanner checks for. I described each method as well as how to manually exploit each of those methods in there, so that will give you a better understanding of what that module is doing, as well as the Paku repo. And then there's my email there if you want to get in contact, and my Twitter is at @SpenGeets. So you can follow me or hit me up on there. So that kind of wraps everything up. I want to thank everyone for coming and listening. Oh, awesome.
So actually, you guys followed me on Twitter when I released that Nation Lab.
Oh, yeah.
Yeah. So
Awesome.
I think Brandon's in the row back as well. He's working with me.
Oh, really? Okay, cool.
Yeah. It's great stuff, man. I like using it.
Thanks a lot. Yeah.
Hey, Chris.
Hey, nice to meet you.
Yeah, that was cool.
Thanks.
Yeah. Nice to meet you.
Nice to meet you.
I will say, I would.
You're interested to hear about that ticket that closed?
Oh, yeah. Yeah, definitely.
You closed what?
Yeah, I reported it that you can do that with no logs and everything, and they just said that's not a security issue and closed it.
AppStream is not one of those that I would expect to do that. I would expect it out of.
Yeah, so it's every one of the unsupported CloudTrail services will disclose that at the access denied error messages. And so I reported that to the Canary token companies, and they all fixed it, I believe, and Amazon just said no. So basically, yeah, if in the access denied error message, it discloses that information, says this user is not allowed to do this, but that this user.
But the ARN was /spacecraft/ something, and so they knew it was spacecraft.
Yeah, and the ARN is not sensitive information. It's just that there's no logs behind it. Yeah. Let's see, I think. Yeah. Okay.
Ah, yeah. All right.
Please
Mike.
make sure that if you say something right now and listen to the way this sounds. Say your name or something. Right now, please speak.
あ、そうや、おいま。
So
Yeah.
you can hear,
Yeah.
and then we know you
Ah.
have good sound. If you do not hear yourself in the phone, then it means we need you to speak up just a little bit. Okay?
Okay.
Thank you very much.
Aye.
This way, of course, the more we speak directly,
Yeah.
the better.
Okay. Thank you.
Warnings last 10, 5, and 2 minutes. Is there anything I can get for you? Anything you need?
No. Okay.
I'm going to go and step out for just a moment. Come back, and I will let you know what happens.
Okay. Thank you. Okay. Hello, everyone. Today, I will give a presentation about evading ransomware protection in Windows 10. This is an inconvenient truth for Microsoft truly. I'll be happy to answer any question at the end of my talk. However, I'm not native, so go easy on me. First, let me introduce myself. I'm Soya Aoyama. I'm a security researcher at Fujitsu System Integration Laboratory Limited and organizer at B-Sides Tokyo. I've been working for Fujitsu more than 20 years. as software developer of Windows. I wrote NS driver, Bluetooth profile, WinSock application, and more. I've started security research about 3 years ago. My first presentation was at AV Tokyo. It's one of the most famous security conference in Japan, and the password is no drink, no hack. So I gave a presentation while drinking at that time. And I hope to enjoy drinking today too. All right, let's get started. May 12, 2017. Do you remember? Yes, it's the day of cyber attack by WannaCry. WannaCry caused tremendous damage all over the world. Ransomware, as represented by WannaCry, Microsoft gave one answer for it. It's literally ransomware protection. This is quoted from Microsoft blog. Microsoft added the ransomware protection feature in Windows 10 for Creators Update as countermeasure against ransomware. The new feature helps stop ransomware from accessing important files in real time, even if ransomware infects the computer. When the feature enables control folder access lockdown folders, allowing only authorized apps to access files. I examined the ransomware protection in detail. This is ransomware protection screen in Windows Defender Security Center. When you turn on, they are displayed. Protected folders and allows an absolute control folder access. We'll look at each item in detail. First, it's the protected folders. Set folder to protect here. Windows system folders are protected by default, it's stated. The system folder is usually C:\Windows\system32. However, the folder is not included in this list. What is the truth? I show you in demonstration from now. And this demonstration is to copy the text file written as hello world to each folder, execute the ransomware program, and checks if the file is encrypted or not. First, ransomware protection is disabled. So very small, but you can see that the text file is not hello world. That is, the file access is not blocked. Next, ransomware protection is enabled. You can see that the text file other than the system folder is hello world. That is, file access is blocked, but not blocked in system folder. Sorry. The truth is, Windows system folder was not protected by default. I think that Microsoft should rewrite the Windows system folder to user data folder. Next, it allows an absolute control folder access. Set application access protected folder here. Apps determined by Microsoft as friendly is stated. What is as friendly? I show you in demonstration from now. This demonstration checks which application ransomware protection blocks. First, I check apps of Windows 10. It's CMD. This CMD is not blocked. I checked PowerShell too. So PowerShell is blocked. Some of the Microsoft products are also blocked. Next, I checked apps of other than Microsoft. It's 7-zip. Zip is very complicated. And this version is not blocked. But this version is blocked. It seems depends on version. The truth is, Microsoft only knows. Do you understand what kind of mechanism it is? I really cannot understand. And this is a mechanism of ransomware protection. All applications have access to all folders by default. When enable control folder access, protected folder and allows apps are enabled. Add apps by allows an app through control folder access screen. And add folders by protected folder screen. Now, I found a vulnerability of ransomware protection. It's simple idea. We can access protected folders by injecting malware into Arrow's apps. There was similar research. Yang Wo's idea is using Microsoft Office. He succeeded in accessing the protected folder using an OLE object with embedded malware. My method is simpler and more effective. I show you in demonstration from now. This demonstration is very simple. I only execute a batch file. You can see that the batch file is not blocked. If you check Explorer with Process Explorer, wow. The Explorer loaded malicious DLL on the network. I'll explain how I injected. Needless to say, it's registry. There is a shell extension list loaded by Explorer. This time, I use this GUID. The actual value of GUID is under here. It's shell32.dll. Even MSDN is written, HKCR is a merging of HKLM and HKCU. And HKCU takes precedence from HKLM. In the case of this GUID, there is a value in HKLM, but not in HKCU. So if you write the value to HKCU, you can change value of HKCR. This is a file encryption process. Normally, the value in HKLM is reflected in HKCR. Explorer read it and load correct DLL. However, you can write a path of malicious DLL in HKCU with user privileges. And its value is reflected in HKCR. Explorer reads it and load malicious DLL. As a result, the malicious DLL load into Explorer can encrypt the user files. Of course, I submitted vulnerability report to Microsoft Security Response Center because I thought it very dangerous vulnerability and I want a little pocket money. However, MSRC said that cannot pay the bounty because this does not meet the bar for security servicing. Unbelievable. We understood that ransomware protection in Windows 10 is useless. Then, how about as an anti-malware application? This is market share of Windows anti-malware application vendors. There are Avast, ESET, Malwarebytes, McAfee, and more. I checked several anti-malware applications. First, Avast Internet Security has ransomware shield. However, my malicious DLL was able to encrypt the text file without being blocked. Next, ESET Smart Security has ransomware shield, but it's the same result. Next, Malwarebytes Premium has the ransomware protection, but it's same result. Next, McAfee has the ransomware interceptor, but it's same result. As far as I've researched, anti-malware application cannot block my malware. Of course, I think there are some applications that can block. How can we prevent this attack? Delete Explorer from friendly list, fix to make Explorer load, signed DLL. Both of these are Microsoft work. What we can do is to always check how, if malicious values are written in the registry. However, I think that this is not the fundamental solution. What is ransomware protection? The ransomware protection feature the prevent file encryption even if WannaCry has crossed the boundary using MS-17 or 10 vulnerability. That is, there should have new boundary here. Until now, account-based security boundary have been defined, and those that exceeded it are called security vulnerability. But now, boundaries that are not based on account words appear. We should reconsider definition of boundary and vulnerability. In case of non-account-based security, I'd like to define security sub-boundary and security sub-vulnerability. Okay, my presentation is over. If you want to see demonstration of live, please catch me later. Thank you very much. Hi. Hi, I'm Saya. Yeah. Nice to meet you.
Did you try running that code as a regular user?
Huh?
So you ran all that under the context of admin? Did you try running it as a regular user?
Sorry.
Oh, no, it's fine. Thank you.
Yeah.
Hi. I'm worried about my audio video, so I'm going to take you up on it in a second as soon as I'm functional here. What? Oh, I like pandas. Uh-oh. Yeah, it's it's not working. Hi. I got audio video problems. It's up? Okay. It's on the slideshow. Okay, if I...
Well, no,
if
so
I-
it's the connection to the laptop is the problem,
Okay,
I think.
Okay.
So let's take a look. Pardon me. So I want to try to relieve the stress on this silly thing.
okay.
Let's, I'm going to try something a little strange.
Here, put it around here. Yeah,
Just
yeah,
grab
yeah.
it from me.
Okay, no, I'm quite happy.
Wait just a minute, see if it wakes up. It takes a second or two.
Yeah. That's not good.
Hold on a sec. Windows, P. With us, not against us. Go back to PC screen only. And then,
Duplicate? Duplicate would work, wouldn't it?
oh sure. But then you don't get this double
Oh,
screen.
okay.
So I don't know if that's what you want. It's acting really strange. When was the last time you rebooted your lovely toy? May I maybe turn off the capture device? The
Sure,
capture software?
Sure,
Would that be
sure.
okay?
I don't think that's what's the problem, no.
No, but anything extra that we don't want to.
So reboot it?
So let's, well, we'll have a minute. So, why is it already running like it's running?
I don't
interesting.
understand.
Because there's a timer, so it thinks the slideshow is.
Oh, okay, so let's just shut off the slideshow and just,
Yeah, and I'll just try to share
just,
it.
share.
Try
That could be
again.
it.
And let's see if it goes.
This is a nightmare. I can't believe it.
Do you have your slides on a thumb drive just in case?
No.
Okay.
I don't have a
And
thumb drive.
it's coming, there it is.
Oh, good.
What? No, and there it goes. Is it up, is it down? Which is it? Is it the only connector on the laptop? Oh, there it is again. And
Okay, I won't move.
no, no. Just have to find a spot.
Is this the microphone?
This is the microphone, and
Okay.
that is if you use this. Just make sure you speak and you have to hear you. So, for example, speak directly.
It comes and goes.
Yeah, no, the laptop is being mean. I was going to try to wedge it in position.
Do you have a thumb drive? Oh,
I'm trying to see if it's up or down, you know? For example, here. Hold on a second. It is the only connector that has stay. No, stay. There.
okay, let's not move.
Nope,
It went away.
it went away.
I might have to do this a cappella.
Well, okay, so here's a. Everyone would be fine if I just held this, right? That'd be okay?
It'll make an interesting video.
I've done stranger things. Yeah, it's really unpleasant there. Okay, so there's a weird thought. Nope, and it's still going. So as long as you can look at every other slide for about a minute and a half.
Okay, I'm going to go ahead and start going.
Okay. Do we have a spare laptop we could borrow for a second? Thanks. Would that be okay with you?
Yeah.
We'll take just a second here.
I'll do the intro right now and introduce you to myself.
Then let me go ahead and start the recording, okay?
Oh,
'Cause I
all
don't
right.
wanna- 'cause
Okay.
we wouldn't want to miss it. So
Okay.
please copy your file.
Into this thumb drive? Okay.
Yeah, it's a thumb.
Okay, okay. I'm not sure what to do here, so maybe if you could do this. Oh, see, I knew I should have done this.
So where is on your machine, where is the file?
It's under Documents,
Uh-huh.
DerbyCon,
Okay, documents,
DerbyCon,
DerbyCon.
Yeah.
Thank you. Thank you so much. And then which one there?
It's the
from
final,
10 to?
latest,
That
second
one,
one. yeah.
okay. Thank you. Okay, so I've got this. All right, set this guy aside. Go ahead and set him up there.
Okay.
And then to get your just correct.
Now, where is it?
So, may I help you with that?
Yes,
Would that be okay?
please, please.
So we go to my little device here.
We're going to be 3 minutes late, but I talk really fast. So, fingers crossed.
Okay, so we do that.
Okay. Now, I thought I'd be really nervous, and I am really nervous, but this last-minute problem solving is really driven all the adrenaline out of me, so.
Thanks so much, everybody. And if we go right here
Yeah.
and hit.
Oh, no, no. No, I'm freaking out way too much to do anything devious. I guarantee it. So, okay.
Would that be okay? Can you work from, well,
Yeah, sure. I'm good.
Okay.
Thank you, thank you. Thank everyone, thank you. Oh, and wait, I see that challenge coin up there? You're gonna get one of those at the end. I got them in my purse. Okay, so you're starting a recording of some kind? Must there be evidence? Hi, Alita. Okay. So, hi, I'm Kate Brew, and I work at Alien Vault right now. I'm the editor of the blog. I started my career in graduating from Georgia Tech. I used punch cards to write code at Georgia Tech. Yep. And not many people can say that. Not many people want to be able to say that, but be it as it may. My first job in security was working in a company that had an IDS for Unix, and it had 41 signatures, and it was wow at that time. So things have come a long way since then. I really got deep into security and when I started with Tivoli, right before being acquired by IBM, and in product management. And I worked at other places. Currently at Alien Vault, which is an AT&T company, and I'm also a volunteer. I like OWASP. I do a lot of volunteer work with our local Austin chapter, and LASCON, which is our application security conference. It's coming up October 25th and 26th. LASCON, yeah, there's another Austinite. I'm married, but my boss says I have a boyfriend named Twitter, and that may well be true. I spend a lot of time with Twitter. Okay, so are you seeing? Are you seeing the next slide? Good. Oh. Oh, you don't want to see that. You want to see the next one. Okay. So a lot of people are like, how do I get started in information security? I hear that quite a bit. Blogging is one of the great ways to make yourself known and to contribute to the community at the same time. And in a lot of cases at Twitter, anybody seen at Twitter late night indecent exposure where people start picking fights with other people and getting really nasty? With a blog, you're going to consider it very carefully, and you're going to have a well thought out piece that you'd like to represent you, that you'd like to put on your resume. And actually, speaking of resumes, I'm very proud that we use a lot of guest bloggers at Alien Vault, and we work with some pretty young ones. And I got to be a reference for a guy when he went on a job interview, and he got down to the point where he needed references, and he got the job. So, because for the employer, it's proof that this person can do good work, they can read the blog, but they also have worked with a corporation. And you can always send a link to your mom, make your mom proud. Okay, so actually Javad Malik helped me with a dry run, and he suggested Kate's 7 tips to good blogs, but I made it Mama Kate's because I I use that nickname, and it's used on me on Twitter quite a bit. The big things are helpful information, things that you would like to read, not a bunch of drivel, not a bunch of fluff. You know, real research or how-tos or helpful tips, something you really care about, something that you're at least curious about. You don't have to start out as an expert, but you're going to end up as an expert by the time you write the blog. The guideline is 500 to 1,000 words, but I've put out blogs with 3,000 words that did great. So longer blogs, depending on the subject matter, can be entirely appropriate. Include pictures and videos. A couple of reasons for that. People prefer pictures and videos to a big, especially a chunk of text altogether without headings. But also Google spiders, which are the way that you get found on, you know, when people search for you, is the crawling of the spiders. And they love pictures and videos. They count them much more critically than text. And I have more on optimizing your blog so that you are found. Especially if you have great content. It's always a shame to me when I see a great blog that's just made a few little errors that would be easily corrected. So I'm going to talk about how you could do that. Get peers to review your blog. Don't let people rewrite your blog. Don't let people Frankenstein your blog. You know, people who are real good at English or something, don't have them do a peer review. Have somebody who understands the subject matter and can verify, yeah, this makes sense, this hangs together. You know, you've explained this well. And then you can have one review with somebody who knows all their grammar and so forth. Do a little rewriting, but don't Frankenstein. Don't allow 8 people to review your blog and take it apart. What you want to write about is a topic that people are actually looking for on Google. The reason I keep talking about Google is you're like, Kate, you know, why don't you just write a blog and put it on social and get a bunch of people to look at it? Because next year, next month even, that blog's gone, unless it gets traction on Google, unless it gets organic traction. So I call it, you know, my job where I run the blog, it's the gift that keeps giving. I can go on vacation because of organic search. I don't have to be there. We're doing all the hard work of figuring out what LinkedIn groups does this blog work with. No. You've got, you know, people are Googling, they want to know this stuff. You're not forcing it on them. Speaking of Google spiders, how do you get the attention of the Google spider? It's an algorithm that's very hard to understand, but very simple in a way. Google spiders are looking for the best content for people doing searches. They're not sinister, except for the ad piece. You know, obviously Google has to make some money, so those ads, you know, aren't done based on the spiders. They're done based on paying money. But that's fine. But as far as competing against other good content, you need to be unique. You can't cut and paste from somebody else's blog. You're going to get definitely penalized, and I think you should be for doing that without attribution. It's got to be unique. A unique finding, if you have malware research, you're going to get links to that blog all over the place. That blog's going to do great. You know, something some people want to share. That's the kind of content you need to be writing. It's helpful and relevant, okay? And I hear all the time, you know, bloggers will say, what should I write about? And first of all, that's a warning flag to me. If you don't have passion as a blogger, wanting to write about InfoSec, don't write a blog because it's probably going to be boring. So anyway, I did try to help these people out, you know, for guidance. And basically, because I love Twitter, I did a poll, and the clear winner was Practical InfoSec How-To. And you don't have to be, you know, a data scientist to write those kind of blogs. You just have to do the hard work, do some research, you know, find things out that you're going to share with the community. Sorry. Tricky concepts explained. They're also interesting. Don't take that number on thought leadership as precise, because I had a lot of people direct message or respond to this saying, I like thought leadership, but between those choices, you know, I like all the InfoSec blogs, and I read thought leadership all the time, and people do. But it's just like, what are you looking for? What would be really enticing? And what jumps out is practical how-to. All right, so the next question is, I got my blog up. How am I going to get people to it? How am I going to get people who I know will share my passion for this topic? How do they find me? Well, obviously Google, you know, or search engine, I should genericize. But one key thing that maybe people don't know that I figured out over the years is authority of the site really matters. Reputation of the site matters. If you publish to a site that deals with spammy or otherwise not good sites, or allows them to copy content, it's a bad idea. And your own personal blog, I have a personal blog, but if I have something I really want to get eyes on, you know, in the InfoSec community, I publish it on the Alien Vault blog because the reputation of the site and the authority of the site and the fact that they do a lot of the socializing as well. So the right thing to do, in my opinion, is to publish on a site with good authority first and then repost on your personal blog. Socialize it. I can't tolerate Reddit. Maybe you can. But if you can, it's great, because that RNetSec subgroup, or whatever it's called, has great information. I just can't tolerate the other stuff that happens there. But socialize on Twitter and LinkedIn for sure. And don't be afraid to ask people to help me out, socialize this. You know, retweet this, please. Almost everybody will do it if it's something that's, you know, you're not obviously trying to make money from or something like that. People are quite willing to help you out. Title it like it is, even in social. Clickbait gets people angry. Say what you mean to say. Don't, you know, try a bunch of games. You can be funny in social, for sure. It's okay to be funny in social, but don't lure people to content that has really got nothing to do with what you've written out. And I have a story, so this was on accident, but we had a blog about celebrity nude photos that, you know, it really was a hack. You know, it was a valid InfoSec story. But unfortunately, because it said the word nude in the title, we got picked up by a bunch of unsavory sites actually linking to our very technical blog. So I guess they eventually figured out there was nothing juicy there. But you know, you need to be careful with the title and just, or even what you put on social, to be very clear to people. Don't fool people. Tag people who've helped you with your research. If you have attributed some of your content to another source, don't be afraid to tag them. You know, at least they know they're getting credit. Everybody likes their work linked to, so it's a win-win. And invest in the time. And I will tell you, I have to warn you, organic traffic is, writing blogs for organic traffic, for traction, for SEO, is very counterintuitive. All that good writing skill that you probably have, it has to be adapted quite a bit. And a lot of authors have a hard time with it. How many people in the audience have read an information security blog in the past 6 months? Yeah. It's where you get the fastest is Twitter, because you can get a tweet out there in 2 minutes. But a blog, you can get a blog live in a couple hours. So if you're looking for the latest on something, it's going to be the best way to get it. And in InfoSec, things move extremely fast. So investing in the extra work is key. So I'd love to know how Google search works. The thing is, nobody knows. Nobody really does know. Well, probably about a couple hundred engineers in Google know. But the rest of the world is just guessing. And some of those guesses can do more harm than good. The other thing is, the algorithm probably changes 100 times a year. They tweak it. You know, they're trying to really do the right thing for the end user who is Googling things. They're trying to do the best job they can to get the user to what they want. So if people are trying to game them, they're on that. You know, and they're working to stop that. Okay, how to optimize blogs. I've been talking about this, and now I get to get the real thing. When you're doing your title, or when you're doing your keywords to start with, think about what would you type in Google to find this content. Start there. A lot of times, people will give me a blog, really nice blog, and the title is funny. It's really funny, and I have a good sense of humor, but I'm like, no. Tell me what you would Google to find this blog, and then we name the blog that. I think the weird thing that took me a while to understand is Google spiders have no sense of humor. They don't know jokes. If you tell a long, convoluted story at the beginning, and it's a wonderful story about your cat, and all the humans love it, but when the Google spider sees that story at the beginning, it goes, clickbait. This person is writing a blog about cats. You got to be really careful about putting your message very quickly out so that Google can find that. Make the title short. You're actually penalized for long titles. Sometimes really technical blogs need to be long titles. You got to do that. Use the keywords throughout the blog. Break it up into headings, into sections. A lot of technical bloggers turn them over to me and I have to edit them. The biggest edit is, I don't want to read a chunk this big of text. I'm a human. No. What you need to do is break it up into little bite size and put the headings in there so that regular people, you know, which is a subset of your audience, regular people are going to want to read it. Use alt text in your images. If that doesn't make sense to you, come see me afterwards and I'll explain what I mean by that. It's a way to tell Google what's in the picture. And in my editor, I just enter it as alt text. So don't even try to game search engines. My strongest suggestion is just write good content. Just provide the kind of content you would want to read, and you'll get the organic traction, kind of without trying. Metrics. So the metrics that I have in my job as a corporate blog editor is number of visits, where they come from, number of blog subscribers, number of views to each individual blog post, and I usually give this feedback to our guest bloggers, you know, to tell them, oh, this blog of yours is doing better than this blog, and here's why. It could be. If they have the misfortune of the blog happening at a particular time where they don't get a lot of traction, there's a whole lot of other things going on, you know, I'll tell them, hey, we might need to work on the timing of when we release the blog. I've heard that some bloggers really love the qualitative feedback. So that's something you don't want to just do sheer numbers. You also want the qualitative. You want to consider that. The average time on blog is indicative of how interesting it was in a lot of ways, and the bounce rate. Whether the people go there and go, this isn't what I want, and bump right back out, that's a ding on your site. Unless you were Brian Krebs, I don't see him out there, my advice from years of this is don't let people comment. What you can do is get your feedback on social. So you can post links to the blog and say, hey, I'm looking for comments. What did you think of this blog? Get them that way. Because when you allow comments, you're actually increasing your attack surface. You're allowing people to inject executable code, things that you don't want. Don't have time to do this, but if you need help with establishing your keywords, this is one place to go. But what I suggest more is find somebody who is an SEO expert, like most companies have them, and just, you know, spend an hour with a person and say, hey, help me out with this blog. Here's what I'm thinking. And they go off and do their research and so forth, and they'll come back with helpful ideas for you. Bad things to do. If you're in a corporation, don't get input from the SEO expert. Ignore the guy. Yeah, that's really bad. These are all things not to do. We talked about cleverness, excessive cleverness. Have no screenshots. Have blocks of text with no videos, images, or screenshots. People will not love that. Even Google spiders will not love that. Plagiarize, steal, never do that. Very unforgivable. And not give attributions to your references, that's awful. And be rude. Blogs done right. Okay, if you Google how to prepare to take the OSCP, Alien Vault blog will be #1. And that blog was written by a 19-year-old from Philippines who had just passed the OSCP, and he was telling people how to do it. That's a good blog. You don't have to be like a rocket scientist. You don't have to be somebody with a PhD. You can write a really good blog based on your experiences. Google Logs for SIM implementation. Alien Vault's #1 under the ads. Google IDS, IPS, UTM, #1. Building a home lab to hunt malware, #1. And I do like to have fun too, so if you Google best InfoSec jokes, #1. Pinterest might have beaten me out temporarily. I have to go check on that. Okay. Key takeaways. Write about what you really care about. If you've been assigned to go write a blog, just say no, you're wasting your time. You know, you got to want to share this information. It's got to be meaningful to you. Optimize, post sites with good authority. By the way, Alien Vault, I'm always looking for new guest bloggers, so come see me if you're interested, or direct message me on Twitter. And this is I give attribution down there, but it's what people think about bloggers and what we really are. Most bloggers are just, somebody who wants to share in InfoSec. Let me preface it that way. In InfoSec, they just want to share what they've learned with the community. That's my last slide. Any questions? I don't know. I think you were first, David, and then Alita. Yes, my son.
What do you recommend for, let's say that your company doesn't have a blog platform to use and want to set your own up? What do you recommend for hosting and...
Easy? The easiest is Blogspot. Sorry? Oh, okay. Well, what do you do if you don't have a corporate blog? So Blogspot, S-P-L-O-T, is so easy. It's phenomenally easy. And it ranks pretty well on Google. I don't know why. But that's the easiest answer. But probably the other thing to consider is going to a corporation. By the way, Alien Vault is not the only corporation who accepts guest blogs. And I don't want to tout my competitors, but if you come see me and you want to hear other alternatives, I'll help you out there too. Yeah, Alita. Yep. Yeah.
Getting funds stolen and everybody suing everybody else, trying to blame everybody else. And
Yeah.
so I don't have any blogs up, and I found Blogspot doesn't show up in Google searches very good.
Yeah.
But I've had one for ages, so I haven't bothered to update it. What do you think about Medium?
Medium's great. So the question was, there's all kinds of problems with other options and Blogspot. Medium is great on LinkedIn, and it will show up in searches, and it's a great option. Of course, it's kind of a competitor to me, so but it is a great option. Yeah. Yes, in the back.
So a lot of places where like Medium and other free spots to do blogs, I always have a problem with my pictures not being good quality or videos having problems with the resolution that they can support. So I didn't know if it was hosting my own. Is it just something I was doing wrong, or?
With those sites, whenever you get something for free, you're getting something for free. So right, they're sort of just doing that as a favor to you, kind of a thing. So yes, there are problems. I've experienced them myself. But if you go with say even a peer list, which is a competitor to me, but if you go with them, they'll help you with that. They have professionals. So does Alien Vault, of course. That will get things right for the author. Okay, no more. I got the stop sign. Thank you so much for attending. I really appreciate it. Oh, one more question.
So I just hashtag retweet at Security Brew.
Oh.
So please make sure you retweet. I don't see your phone. Retweet. Keywords
Oh, yeah, yeah, yeah. Okay, so yeah. I was running out of time. I was going on this time, and I'm like, wait a minute, I don't have that much time. Okay, keywords. Yeah, keyword tool.io. Hi, how are you?
Thank you.
Are you here, like for the whole week? No, I'm you came to my talk. Oh. Oh. Of course. Oh, let's do lunch. I'll get the lunch this time. We'll go someplace fun. Okay.
Carol sent to tell you she was sorry, but they didn't have the money to do the CTS challenge, so she got a group of women together.
Oh, no, that's cool.
She told me to tell you that.
Oh, that's cool. Okay. Hi.
Thank you for I should follow you on Twitter, but I had a question about the unique content.
Thank you. I need to give you your challenge coin. No.
So I was told that one way is to help to get into the industry is just to blog about what
Yes,
you're doing.
yes, it helps.
But if you're also a blog with my own journey, but is that unique enough? Like, so, I'm doing kind of like other people's tips.
So what do you want to write about?
Well, like, we're helping the CTF, learning how to,
Oh, the how-tos? So
well, I'm learning, so I'm kind of like helping.
as you're learning, right, so I had a guy who did his first CPF, and he wrote a blog right afterwards. That blog still gets like 300 visits a week a couple years later, because it was his real experience of doing his first CPF. Those are great.
Those are unique enough.
Yes, for sure. Newbies is a big topic. A lot of people Google for newbies.
Okay.
I want to, yeah.
I love Kate Brew! Kate Brew, I love you!
Oh, thank you, Manny.
Kate Brew, you're my hero!
Goodness, thank you. Being on Twitter. Yeah, DM. Security Brew, yeah. I'm going to give it to the guy who lent me that computer because he was very nice. Very nice. Did you give the thumb drive back to Sciatic Nerd?
Thumb drive on there. I think you copied it to my desk.
Oh, right, he did. And you took the thumb drive.
Oh, no problem. The next speaker, yeah.
Remind me of your name, anonymous hero with. What's your name? Okay, cool. Am I already following you on Twitter? No? Just Rainmaker, all one word? So I added. Yeah. Okay, cool. Thank you so much. I gave you a shout out, but not directly because I didn't.
No problem. I'll just DM you. If you need anything at all, seriously, I got it. Like, a bunch of guys are willing to help out.
Appreciate that. Thank you. Let's make sure.
No, I don't see it. I don't see it. Yeah, I have HDMI. Do you know where is it? Okay.
There you go.
Thank you. Let me see. Yeah. Totally understood. Yeah. Thank you. See? Do you have water? Do you have water? Okay, thank you. Cool, yeah.
Let's see if we can get you a little glass or something.
Okay.
So what we'll do is we're going to tell you 10, 5, 2 minutes.
Okay. Where are you
I'm
going?
sitting right there next to you. I'll hold a little salt. Now, we need you to talk right here and say something into the microphone if you can. I mean, you have to be really kind of close. It's
Okay.
frustrating.
It is
But,
closed.
So if you can't hear yourself ringing back at you, that means we need to hear you.
Okay.
So speak up, speak clearly, speak right.
Okay.
I don't need you
Yeah.
to, you don't have to reread it, but
Okay.
I just want you to be aware, right? Because otherwise.
Okay. Hey, Shan. Oh, thank you, man. No problem. Okay. Ready? Okay, so hello all. I am Sebastian Castro, and today I'm going to share with you a research I have made on Windows persistence. I have named it RID hijacking, maintaining access on Windows machines. It's my first time DerbyCon here, so I am quite excited to be here. Thank you. I hope you all enjoy this. So this is about me. I am an InfoSec nerd. I like exploit development. I am a Windows security enthusiast, not an expert, in fact. My first logo was 25 years ago, and I am a Microsoft Paint artist, as you can see here. I am the current technical research lead at CSL Labs. That is a company that works mainly providing ethical hacking services to organizations working on the financial sector. I have been working on the field as a red teamer, mainly as pen tester and researcher for about 6 years. Okay, this will be the quick agenda of the talk. I will first expose the attack and how it looks like. I will briefly expose the Windows security architecture related to the logon process. Here in the hijacking the RID, I will point out where exactly are the security issues that make this attack possible. And after that, a live demonstration of attacking against a Windows 10 machine I have updated this morning. I hope it will work. And some final conclusions. So let's meet up the RID hijacking attack. So what is this? This is a new post-exploitation vector which is reliable on all Windows OS versions since NT. I have tested it from XP to Windows 10 and Windows Server 2003 to 2012. It creates a stealthy access on the target all by using only OS resources, meaning that no noisy extra files are needed to take advantage of the some integrity issues that I have found that are exploitable with this attack. It is currently reliable on domain joint machines, but not on domain controllers yet. I am working on a similar attack that can be reliable on domain controllers. In short, this attack modifies the RID of an existing account and sets it up to another one. Just the RID, meaning that all the other account properties associated with the user, such as password hash, account status, etc., keep consistent before and after the attack. By hijacking the RID at the exact moment, the privileges will be spoofed. And one cool thing is that no matter what the hijacked account status is, active or no, the hijacker account will retrieve its privileges as on. So remember that only the relative identifier is modified. So an attacker could log on with a specific set of credentials he already owns and get access as another user. Depending on configuration, it will be possible for him to access remotely via RDP, PSExec, and so on. And besides the privileges stealing, the system will register any operation which has taken place during the hijacker session as done by the spoofed account. And of course, this technique is reboot persistent. So this is how it looks like. In this image, we are running a CMD as the guest built-in account. We can see it, but see in the output of the whoami command. We are still members of the guest local group, but we have writing permissions over the system32 folder, which is pretty cool, I think. So to understand the magic behind this, I will briefly explain how the Windows logon process works. The thing is that I am not that pretty good at Paint, but well, I'm terrible. Well, I think that the Windows architecture is pretty similar to the security concepts of some buildings I have been on. So you introduce yourself in front of the guy who is in charge. Then he verifies you if you are registered in their database, and if you are, then he provides you an access card which permits you to get into the zones you are allowed to. So let's assume that this green guy will be the representation of the administrator or building account. This red girl will be our main character that will represent an unprivileged account, for example, the guest account. And the bad blue will represent the Windows security, and this ugly building, the Windows OS. Imagine that inside of this building, there is an RFID-alike control system which is based on the access card the blue guy provides us. To keep it simple, I have drawn 3 floors. I know there are a lot of more privileges, but it's really hard to draw them all. And depending on configuration of the access card, users shall enter inside some specific floors. So this is the Windows security architecture in a more technical way related to the login process. But as you can see, we are ignoring the modules related to the AD authentication. That's because the RID hijacking is focused, takes advantage of the way that Windows handles the local user's login process. So we are going to be focused on the LSASS, the MSB10 DLL, and the SAM server DLL. In a nutshell, the login task is like this. I'm sure many of you have seen this before. So when a new user authenticates through WinLogon, LSASS verifies its credentials and creates an access token to identify his security context to define the security context. And after that, after creating the access token, it will verify this access token against the objects the user is trying to access by using their own access control lists. Okay. Here is the structure of the security identifier. That is the way that Windows has to define, or the way that Windows has to identify the security principles, such as users, groups, or computers. The first part in yellow, we can see here that it's the one which differentiates off the machine or domain among others. But the last one, the relative identifier, can be the same across all machines. For example, in every Windows machine, as you may know, the 500 relative identifier is associated with the administrator built-in account. So keep in mind that every user account, local user account, built-in or not, has its own RID. So let's suppose that the administrator wants to log on. So he provides its username and password to WinLogon. To do that, Windows needs to initialize some tasks and connections between processes. Right after, WinLogon calls Logon UI to grab the credentials by using credential providers. And with this information, WinLogon will create a unique logon SID to identify this logon attempt. And now, Windows retrieves the handle for an authentication package, which are used to verify the authentication policies of a logon attempt. Remember that we are focusing on the MSB10 DLL of an authentication package. So WinLogon sends to the authentication package the username password combination with the created logon SID, and then this critical step, the MSB1 sends the user password combination to the SAM server, which retrieves the related security information, including the user security identity. And now, to sum it up, the MSB10 checks the information retrieved. If it is OK, generates another identifier called LUIT for the current session and sends back the logon information to the LSASS, including this new identifier. All this data will be used by the security reference monitor to define the security context of the user. So we will see that in short. Now that everything is OK, the Windows Security Subsystem proceeds to create the access token for the recently authenticated user. So the access token is used to define the security context of a process. This object is created by the security reference monitor for every user session. It's important to know that every child process inherits a token copy of their creator's one, meaning that every process within a user session will be executed with the same access token. So continuing with the authorization task, LSASS receives the logon information from MSB10 and checks up its own database to determine the user's allowed access. This check is done by using the security identifier of the user. Right after, LSASS adds to the initial access token the related groups, SIDs, and privileges which are associated with this user. And finally, the primary access token is created. Later, WinLogon will call user inits and stuff to initialize everything, but we're not concerned about it. Then LSASS provides the access token to the user session, allowing him to access. Now he can get into the VIP zone. Okay? Yeah, cool. So now that we went through the Windows standard login process, let's take a look at the thing we're interested in. Where in the process are something exploitable? So how is the user identified by the system after being successfully authenticated? It is identified by its associated security identifier, which is unique within the host. How does the system associate a username with his security identifier? With Blackmagic, of course. This is one of the things I have analyzed and versed and debugged to find the security issues. So let me show how this works. So do you remember this part of the process? Here is the exact moment when a username is translated to his associated SID for the very first time. And then some important data is obtained from the SAM. So how is the username associated with the SID, and what security information is retrieved? The SAM server now has to translate from username to SID. He goes into the SAM database on this specific registry Hive, and then selects the username. Each of these keys contains a reg binary, as you can notice here, and these registry binaries have an attribute called type. This attribute contained an hexadecimal version of the relative identifier associated with this user. In this case, is 3E9, which is equal to 1001. Now that the SAM server knows the related RID, he looks at this registry place and chooses the one whose name is the same RID with some significant zeros, and then it grabs all the information stored into the reference key. And SAM server sends back all this data to the MSB1 process, and this is the security data that is returned back to the authentication package. After understanding this process, some questions may arise. So, why does the SAM store only the RID? Because every user will have the same SID initial part, but the RID will always be different for each of them. The only thing that varies from user to user is in the same system, is the RID. What information is retrieved from the SAM? The data obtained from the SAM of the registry contains the password hash, the account status, some additional account restrictions, and the pivotal one, a copy of the user's RID. This is the core of the RID hijacking attack. We'll see that in short. So let's exemplify the attack. Let's do the authentication process with the red girl, but now we will omit some parts of the authentication process and explain in more detail the exploitable one. So guess it's just an example, remember. This worked also on standard user accounts. So omit in the beginning, when logon has done his job and sent the logon information to the authentication package MSB1, and now MSB1 sends the user hash combination to the SAM server. Now the SAM server queried the SAM database looking for the associated guest key. It determines that the guest account has the RID 501 or 1 of 5 in hexadecimal base. So SAM server queries again the SAM, but now consulting the 0000001F5 key. Now the process retrieves the security data related to the user, including this RID copy I told you is important. After that, SAM server sends this information back to the MSB1 authentication package, and this guy does his job. So this could lead to two possible scenarios. The first one is that the hacker girl will not authenticate because on every Windows machine, by default, the guest account is disabled, leading to an access denied. Then is the second one. So suppose that for some reason the guest account is enabled, she receives her access token, and then, well, she doesn't get kicked out, but has access only to the guest floor. So how could we improve this situation? It's a mystery for us right now to understand why there's a copy of the RID inside a key with the same name, but what would happen if we modify it? Well, I have found that this RID copy is the value used by the LSASS and Security Reference Monitor to create the primary access token. So the privileges added to the access token are obtained based on this RID. So let's set this RID copy with another RID. In this case, the 500, which belongs to the built-in administrator. So now repeat all the process. MSB sends the user hash to SAM server. SAM server queries the SAM database with the guest username. Then it retrieves the associated RID key, which is 1 of 5. Now it queries again the SAM database with the obtained RID. And now it receives the security data from SAM, including the modified RID copy. This data is sent back to the MSB authentication package. Now that the MSB1 authentication package checks for security restrictions of the user obtained from the SAM security data. So it compares the restrictions with the data obtained from the SAM. The thing is that MSB1 takes the status of the guest account, but assumes that they are from the administrator, allowing the access even if the administrator account is disabled. As I have told you, the only thing that we are modifying is the RID, not the other security properties. This applies also to the hash. So MSB compares the cached version of the enter password hash, the hash retrieved from the SAM, and profit. Password will be the same. Now that everything is okay, the authentication package retrieves the logon information to the LSASS, and then LSASS communicates with the security reference monitor to create the access token based on this modified RID copy. So all the security properties of the account remain the same except the RID, which is the critical one. Modifying the RID at the exact place is equal to acquiring the privileges of a spoofed account and doing everything you want. In this case, the guest account receives her access token, and she can do anything inside the system on behalf of the administrator. So these are the security issues. The first one is that the SAM server does not check if the RID associated with the user is consistent to this particular RID copy. The second one is that the LSASS does not corroborate the relative identifier with the username right before creating the primary access token. The third one is that the LSASS never looks for RID inconsistencies during the user session. So the funny part, the demonstration. So let me see. This will be our victim machine. As you can see, I have updated early this morning. Yeah. Okay, and here are the latest patches. Here are the local users of the victim, the administrator one, the guest one, and a standard user account called unprivileged. We can see that the administrator account is not active. We can see that the administrator account is active for our demo purposes. Okay. And this is the standard account we're planning to use also. This is active, and okay. So let's lock down. And let's try to interactively authenticate with the guest account. I have set a password before. We can see here that it is not possible for us to interactively log on as the guest account. So I have developed a Metasploit model, which is available on the latest official version of Metasploit. You can see it on, you can find it on Windows Managed RID Hijack. Post Windows Managed RID Hijack. This is the model. These are some of the properties. We'll see that in short. This is the IP address of the attacker machine. And we will try to do a PSXX against the victim and by using the guest credentials. So if we try it, it is not successful by now. We can try it also with the unprivileged account. Okay, it doesn't work. And let's see the model. So this requires a meterpreter session to modify the specific registry binary that contains the RID copy. So the get system will try to acquire the required privileges to modify this particular binary. The guest account boolean will define if we are going to use as the hijacker account, if we are planning to use the guest account as the hijacker one, sorry. If we want to change the password of a hijacker account, we will set it in the field password. And in the field RID, we will set the relative identifier we're planning to set to. And the session or meterpreter session. So if we're in exploit, we can see here that we have modified from the guest account default RID, which is 501, to the 500. So if we try to authenticate again with the guest account interactively, let's see. Okay, by now it's possible, but let's see what happens if we try to do that with the PSXX version of Packet. Cool, we'll go to shell. And by default, in packet version, the PSXF version of InPacket will try to acquire the most important privilege, which our system account. So let's wait here. Well, the thing is that we are impersonating the administrator built-in account. We can see here that it is disabled. The guest account is enabled. We are authenticating with the guest credentials, but we are generating our access token based on the administrator already. So let's check this. Can you see this? Okay, cool. Now we are the guest account, but our SAD or access token is generated with the 500 access token. Okay, so if we run something like and we try to write inside of a protected folder. Okay. Okay, it will be possible for us to write on protected folders by using the guest credentials. And no triggering, triggering any alert on the victim. You can see here that it is also, the user is disabled by default. Okay, but we are impersonating the administrator. So in every log, every log that registers any operation that has taken place during this session will be registered as done by the administrator, but we are logging with the guest credentials. This is also, I forgot to do that. I'm running out of time, but it is possible to do this also with the standard user accounts. And some final conclusions. So by now, as you have seen, this is the latest Win 10 version. There is no existing patch to protect Windows from this attack. The only way to defend a machine against this is by detection. I have tested this with many antivirus, but it is not detected. I mean, the only thing that can be detected is the Meterpreter executable, but this can be done also by using only OS resources. The thing is that this is more complicated to detect on big Windows domains, since a simple workstation can be used as an open door to pivot inside the network. I am not currently aware about any malware that uses this kind of persistence. I mean, as you see, this is a quite simple technique, and it's pretty easy to apply. I hope you will enjoy this technique as much as I do, and thank you for coming. That's it. You like it? Great. Thank you. Thank you, Sean. Thank you. Thank you. Yeah, the thing is that this is a persistence technique. So you are modifying. So it's a stealth technique. Yeah, you are modifying only 2 bytes of the range. It's persistence, right? Yeah, have you seen the...
That was awesome. Thank you. No, really slick persistence.
Thank you.
I'm wondering if this is something that's
Yeah, I don't know.
symptomatic of some other issue.
They will need to change some parts of the architecture, you know, because it is currently now not. Yeah, sure. Do you like it? Thank you.
Remember to breathe. Breathing's important. Don't touch anything. Good. How are you? It is not.
So we need to see if we can get this to the next one. I'll go see if I can find it. So, as a note reminder, if you can't hear yourself ringing back at yourself, probably a better idea to lean in just a little bit more.
Okay.
So if you can hear the ring of you, then that should be a good level.
Okay.
So the gentleman will be taking care of you going forward.
Thank you.
It's live beat by do you have any needs?
I think I'm good.
Okay, so you'll get a 10-minute, a 5-minute, 2-minute flag by sign down there behind us at the table.
Yep.
Thank you very much.
All right, thank you. All right. Uh-oh. I think...
Be careful. Okay, so if you can, you might want to thread something like HDMI cable on the side of the podium so it's not pulling this hard on the connector, because it looks like that's causing a signal to go. So over the top. Right, so it's staying on the edge of the... And then, no touching.
Right. Okay. I can't see that screen, so if it goes out, let me know. Okay. Hello, everyone. I'm Ryan O'Grady. I'm a research scientist with a small research company called SOAR Technology, and we focus on artificial intelligence, and in particular, I focus on the intersection of artificial intelligence and cybersecurity. So I'm just gonna say this up front. I get nervous, and when I get nervous, I talk really fast. When I talk really fast, so if I start talking too fast, just shout, slow down, okay? Otherwise, we'll be done in 5 minutes. So this talk is, your training data is bad and you should feel bad, and hopefully ways to make you not feel quite so bad. So how did this come about? Well, I had a pretty simple question. Can I detect botnet command and control on Twitter using machine learning classifier? So I started digging into that and going, okay, well, there's all these tools out there. All I need is some labeled data, right? Well, that's easier said than done. The availability of data is low. Labeled data is almost non-existent, and recent labeled data, forget it. You just give up and go home. So then I started thinking, well, I found this data set from 2011. That's good enough, right? And it got me wondering, trends change, how people use technology changes. Is that data actually meaningful anymore? So I asked myself the question, how does data age? And more formally, to what extent does the recency of training data affect the performance of machine learning classifiers trained on that data? In other words, can I use old data to draw meaningful conclusions about new content? So what I was really interested in was, is a given tweet or set of tweets or account really a bot? Well, as I said, I don't have good data for that. So I thought, okay, if I want to answer this question about the recency of data, what information do I have? So I decided that verified as a stand-in for trusted is a reasonable place to start. So I started looking at, can I determine if a tweet comes from a verified account? Now, I know a lot of you are thinking that's not the same as a bot. I know, but we have to start somewhere. So in order to answer this question, I needed to collect data. Thankfully, that's already labeled data. Each tweet includes whether it's from a verified user or not, so that makes my life easier. So I just need to go out and collect around 1,500 tweets for each year. The verified program was initialized in 2010, so that's where I started, was 2010. Thanks to the kind people at Twitter and the limitations they placed on the API, that meant I had to gather 4 million tweets. And I can get more into that later if you're interested, but basically you can only get the 4,000 most recent tweets. And for a verified account, that might be a year. It might be less. So for each year, I trained a classifier with data from that year and then tested it against data from every other year. So in 2010, I trained a classifier on that data. I then tested it against determining if tweets are verified or not in 2010, 2011, 2012, and so on, up to 2018. That gave me the data that you see in the upper left there, which is kind of a square year-by-year grid. But that's not how I think about the data. How I want to actually think about the data is, what is the offset between the training year and the test year? So you can see I shifted all the data so that all of the +0, meaning 2010 training data and 2010 test data, 2011 training data, 2011 test data, all lines up. And all of the conclusions I'm going to discuss are based on that representation of the data. You don't need to be able to read that, don't worry. I'm just showing you how that process works. So how did I actually measure the performance of these classifiers? Well, the first thing you're going to find if you start looking in machine learning is accuracy. Accuracy is a garbage metric. I didn't use it for reasons I'll explain. It's especially bad for what are called imbalanced classes, which for verified, that's exactly what it is. 95% of accounts are unverified. So what does that mean? If I'm a lazy machine learning classifier and I just say, yeah, sure, it's unverified, I'm going to be right 95% of the time. But I didn't do anything. So we needed to find a better way to measure performance. That's why I settled on the Matthews correlation coefficient. It uses all the elements of a confusion matrix. I won't get into that, but the bottom line for us is that if a lazy machine learning classifier says, yeah, sure, it's unverified, the correlation coefficient is going to be 0, meaning no correlation. It has to actually make predictions about the least and most popular class, in this case, unverified and verified, in order for it to actually have any measurable impact on the correlation coefficient. I put an asterisk here because it doesn't matter. There are some edge cases where you just say it's equal to 0 and you just move on. But by and large, if you're predicting 0 for all the classes, this is going to be 0 at the end of the day. Each classifier was trained using three sets of features. The first is tweet-only features. Those are features of the tweet itself. The content, although I didn't actually use semantic content, I do want to make that clear. When it was made, how quickly it was made from the previous tweet, and so on. The second set is user-only features. These are features associated with the user account and not the tweet itself. When was the account created? How many friends do they have? And so forth. And then, of course, all features is both the user features and the tweet-only feature sets combined. So now getting to the actual meat of what I found. The first finding is that classifiers perform best at a +0 year offset. This means that if you train with data from 2017 and test against data from 2017, that has the peak performance. As you start moving away from a zero offset, either positive or negative, performance decreases. Now, I know you're not gasping in shock. That's not a terribly surprising conclusion, but it's an important conclusion and one we want to be able to prove. There are some more interesting things in there. The performance of different classifiers varies. So any of the ensemble classifiers tend to perform best. Those are things like random tree, gradient descent, anything that combines multiple classifiers into one and can have a bucket approach. SVC fared the worst. Its +0 offset performance was not bad, but it quickly approached 0 as you moved away from 0 offset. I should go. When you look at these numbers, the 0.98, 0.91, and so forth, that's the Matthews correlation coefficient, which can be interpreted as Pearson's R. That means that a value of 0 is no correlation, a value of -1 is perfect negative correlation, and a value of 1 is perfect positive correlation. So what you're really looking for is a value approaching -1 or 1. So here you can see side by side the performance of the classifiers, the mean performance of the classifiers for the tweet only versus the user only feature set. You can clearly see that performance is optimal at +0 offset, and it does drop as you go positive and negative. You can also see that the user-only feature set performed significantly better than the tweet-only feature set. Finding 2, feature importance changes over time. Again, not really shocking, but I just wanted to make it clear that if you're using the same feature set that you derived in 2010 as in 2018, your performance is going to degrade. Using the tweet-only features, performance didn't really degrade because it wasn't good to begin with, so it went from bad to bad. For the user-only features, though, we saw a significant drop from 0.62 to 0.39. The biggest change was in the user friend count. So in 2010, your user friend count was a strong indicator of whether you're a verified account or not. In 2018, that's no longer the case. What this research doesn't do is try and answer why these features changed in the way they did, but that would be good future research. And here you can see a plot of the user-only features on the top and the tweet-only features on the bottom. There's a bit of an odd drop in 2017 that I couldn't explain, but the trend does hold. The third finding, adding more features doesn't necessarily increase your performance. That's an old, I don't know how old it is given the field, but it's a machine learning axiom. More features is better. Bullshit. I'm saying right here that if you add more features, if you add the all features, you add the tweet-only features into the user features, your performance is getting worse. I can't tell you how many of my colleagues I talked to trying to figure out what features to include, and they're like, just throw it all in there. You know, it's fine. It won't hurt the performance. Well, yes, it will. So you can't just skip the feature selection and feature extraction step of creating a machine learning classifier. That's an important step, and if you skip that part, you're going to hurt your performance. I should point out that certain classifiers were less susceptible to this. Again, the ensemble classifiers tended to fare better when you started adding extraneous features in there. Others, like SVC, I don't mean to pick on SVC, but it totally trashed its performance. So here you can see, again, the user-only performance is on the left, and it performed pretty well at +0, and it dropped off, but even at 0.6 on the left or 0.5 to the right of the user-only features, that's still a pretty positive correlation for performance. But once we added in the all features, added in the tweet-only features to that set, it only dropped the performance across the board. So what's the bottom line here? What does it all mean? Again, I don't want to shock anyone, but training with contemporaneous data is going to get you the best performance for your classifiers. That means, unfortunately, if you decide you want to go out and create your own Twitter bot classifier, you're going to have to figure out some way to get relevant recent data. If you just go and find some data set off the shelf that's been sitting there for 5 years, maybe you'll get some good data, make some good results, or maybe it'll get no better than noise. There were some of these classifiers that, by 3 years out, either positive or negative, were performing no better than if I had trained it on noise. And the conclusion you might draw if you're not careful is that your classifier or that approach to classification is faulty, when in fact it's just bad data. Again, machine learning isn't magic. Garbage in, you get garbage out. You have to be careful with how you select your training data. You have to be careful with how you decide which features to include, because including extraneous features can hurt your performance. And don't skimp on the actual feature selection itself and feature extraction. I just want to spend a moment to talk about, what are some of the future directions that I can see this going, and it points to some of the limitations of the research itself. So what I've done here is said, can I use data to determine if a tweet is from a verified or unverified account, with the assumption that that has some correlation to determining if a tweet is from a botnet or a non-botnet account. That's an assumption that needs to be explored. Does the same approach hold true given good botnet data? And then the Twitter limitations that I talked about, is the performance that's being observed here in spite of those limitations, or is it some artifact of those limitations itself? So for example, I could only use verified accounts that had tweets from 2010 up to 2018. That right there is a limitation and a self-selection criteria where a lot of other accounts were left out, especially high volume accounts were left out because they put out 4,000 tweets in the last 2 years. Well, I couldn't use it. So what you really need is access to the full data stream so you can do proper random selection of the accounts and get the full set of data for any given account rather than the limited set you can get for the free API. Unfortunately, I didn't have $100,000 lying around, so I had to make do. And then finally, what would be the effects of including the semantic content? I left aside the tweet content itself entirely. Usernames, I didn't consider those. How does that affect the performance of any of these classifiers if you start looking at what they're saying? What is the sentiment? Do sentiment analysis, semantic content analysis, any of those things to try and get a better sense of what is the actual content of the account rather than just the characteristics of the metadata. So if you want the full paper, it's available in the SANS reading room. Or if you trust a shortened link, there's the Google link. I did this research as part of the SANS Master's Program. I'm excited to be part of that, so if you want to talk to me about that, I'm happy to talk to you more about that program too. So I didn't go too fast, but I still have plenty of time left, so I'd be happy to answer questions at this point. So just to ask myself a question, one of the things I'm often asked is why do you see this performance? Why is there this degradation in feature mutual importance? And I couldn't answer that as part of the research, but I have given some thought as to, what's going on here? Why are features becoming less meaningful over time? And I suspect it might have to do with the fact that as the Twitter base grows, as it becomes more diverse, individual features are no longer as meaningful. You have accounts from all over the world. You have accounts from all different ages. So I think that as their base is growing, it's essentially watering down the significance of any given feature and decreasing what you can derive from that information. Yeah.
Did your features for this include whether or not there was a link in tweet?
It did not. There was actually no content analysis whatsoever. So if you want to see the features, so the tweet-only features, they're more or less Boolean features. Some of them are numeric, like how long has it been since the account was created. I didn't do any kind of, was there a link, was it a retweet? Actually, I think no, sorry, is a retweet is one of the characteristics, but it didn't, for example, look at, okay, who were they retweeting? Was it another non-verified account versus verified?
Although that's another interesting side. You could do like graph analysis or something in botnets, sweet botnets.
Yes, and actually, shortly after I finished this research, a couple of researchers, I forget out of where, announced they had discovered a roughly 400,000 botnet account called the Star Wars botnet, which, you know, I would love to get my hands on their data, but data sharing is its own quagmire. And if you want to look at the features for users only. Yes, ma'am. Mm-hmm.
So those are evolving too.
Absolutely.
I don't know, when you refer to semantic features in that question for the future, if you were referring to something specific in Twitter or just in general?
So, I mean, you can do semantic analysis to try and, you know, reconstruct the actual content and say, you know, you can determine the language. I actually toyed with that. You can determine, is it content from somewhere else? You can do sentiment analysis to try and determine it as a positive or negative tweet. There's some more advanced techniques I'm not all that familiar with to try and, like, essentially determine if it makes sense. Like, is it and in Twitter that I realize that's a bit of a sucker's game, but I haven't explored any of the actual sentiment analysis approaches. I filtered for English tweets. Yep. I filtered based on the language field specified by the tweet itself. There is a field that can specify what language the tweet is in. A lot of them come through as unknown. I didn't use those. I used only EN tweets. Yeah. Yes.
How did you determine what type of classifier is best for your data? Because like you have primarily all the data that falls into one class, six plus the other class.
Right.
With underverified versus verified.
Mm-hmm.
I saw you use a couple of different ones, but how did you know where to begin for like which classifier to use best?
It was trial and error. Actually, a lot of this was trial and error. And part of what I wanted to see here was how various classifiers perform. So as you can see here, I did use 7 different classifiers, or six or seven, just to compare their performance. So the answer to your question is I didn't decide. I just chose some based on what's popular and what seemed to make sense for the data. There was a before any of the rigorous science started, there was a fair amount of just exploring the data, looking at, you know, what are the mean, median, mode for various fields, you know, what are the outliers, that kind of thing. And then I started homing in on like what I actually wanted to extract as features and what classifiers I wanted to use. I can tell you there were several long afternoons spent waiting for, you know, a k-mean classifier to finish up because I was using 30 features and that was going to take it 200 years to finish, and I didn't realize that until too late. So, yes.
Did you do any analysis of whether the changes we're having year over year were different in the negative cases versus positive cases?
Did I determine if there was changes in the negative versus positive year after year?
I guess what I mean is, like, it seems like the data set on which you're testing is changing over time, which is validated as effectively the model. Do you know if that's changing similarly in the positive cases, the verified accounts, or the negative cases, where it's like the background noise is getting shittier and but the verified accounts is getting the same?
Oh, I think I see what you're saying. So, no, I didn't. And actually, I'm going to point out, you know, another shortcoming in my research, which is user data is as of the time you retrieve the tweet. Okay, so when I go and get a tweet from 2010, the user data is from 2018 or whenever I capture it. If the user data has changed significantly in that time, of course that's going to be reflected in the up-to-date, whereas the tweet-only data is as of 2010. So if I get a tweet from an 8-year-old account, the tweet looks like it did back then, but their friend count, you know, number of retweets, all that is going to reflect current time. And that's just simply a limitation of the data that's available that without capturing data across time, like I started 8 years ago, I don't have a good way to counteract that. Any other questions? All right, well, thank you very much for your time.